safety is characterized not by the absence of risk by itself, but the absence of unacceptable risk. And that means that any body, any human being, any organization will put its own sense in this unacceptability. Unacceptability or acceptability is connected to a level that organization or a person can tolerate. So you decide what is tolerable for you and what is not. And here, the organization must take into account its legislative obligations and its policy in the sphere of health, protection, how we can reduce risks. This is in order of priorities. First of all, the most important and the most reliable is to reduce a very secure project. If you can think beforehand about all possible risks, about all damages and such things, and can give remedies to it, that will reduce risk for you and for your project as well. The second thing, use of protective devices and personal protective equipment. Personal or collective doesn't matter. Information on installation and use of any equipment. And the fourth place is training. Maybe because the human factor always presents, so training is very good, but sometimes things happen. People like very much to make all the things formalized. It's very useful. So we have a lot of standards. A lot of them. Maybe, for sure, you dealt or are dealing with these standards. And you can see, I think very familiar to you, the family of ISO standards, International Standard Organization. In Russian legislation, we usually take these ISO standards and transform them in our national standards, but they are very similar. So, four main groups of standards. The fundamental ones, group standards, product safety, and product standards. Here you see the risks, different kinds of risks of company, and different standards. So I think that this list is not complete. You can think out a lot of other risks depending on your own activity, professional activity. But what is interesting for us here is environmental risk. And then here we have a family of standards, ISO 14001. Maybe it's not commercial for you. I don't sure I'm right in English pronunciation of this. Okay. We will go back to this slide. But now I would like to give you some examples to explain the difference between these four groups. Okay, see, fundamental standards. Say, risk management principles and guidelines about everything. Risk management code of practice about everything again. But here we have nuclear, radiation, radioactive waste, and transport safety requirements. Not about everything, but it's fundamental, nevertheless. Group standards. Look, risk assessment, but not for everything, only for machinery, safety of machinery. Yes? Again, potentially explosive atmospheres. Risk management, but for projects. Group standards. And the product safety and product, we won't speak about them. They're not in our field of interest now. But here, safety for roads, safety requirements for electrical equipment, and here just very specific things, gas cylinders and so on. Do you familiar with the ISO 14001? No. This standards is environmental management system that are very broadly implemented in Rosatom, for example, in Russian nuclear power plants. What environmental management systems, guidance and requirements? Is it fundamental or is it group standards? What do you think? Fundamental. Yes, I think so. That like this, radioactive. So we have environmental management systems, almost about everything. Environment is just by the word itself. Okay. Peter, going back to your definition about protection, you see that here we have two definitions. One is from the I recommendation, and the second one is Russian. Again, it's almost impossible to argue about if a specific definition correct or not, because they apply to specific areas of activity or specific situations, or they are coming from specific purposes. So here we have safety as a protection of people and the environment against radiation risks. We have here IA Safety Standards 2018 edition. And the safety of facilities and activities that give rise to radiation risks. So not only the protection against risk, but also safety of facilities and activities. Included the safety of nuclear installations, radiation safety, radioactive waste management, and the transport of radioactive material. Actually, it applies to all radioactive sources, including tailing dams. Do you know what is tailing? Tailings? Who doesn't know? Shall I explain it or not? Okay. When you process ores, included radioactive ones, you have some useful materials, you take it and process, and then you have some useless, empty, and you put it somewhere. And you have, according to the technological specificity, you have a kind of tail. Tailing means not just heaps of these ores or rocks or ground soils. They're very complicated constructions, including place for putting these materials, dams to prevent them from flowing out of the place, some auxiliary construction, so on. So it's a complicated construction, and if you don't care for it properly, you can have a lot of problems. Say in Central Asia, I was at the place with the IA mission. It's Kyrgyzstan, Minkush. You heard about it, yeah? The abundant tailing. There was a very rich settlement there. People from all the country, all the Kyrgyzstan, used to came there to buy something because the goods they were transported from Russia, from Moscow to this place. This is a very big factory for uranium mining. Now that's almost nothing, and there was danger. I would say it was a danger because the remediation of this site is almost completed. Russia, Rosatom, and Germany. But if they put all this on place, there are slide over the tailing, and if the slide goes down, it put the river closed, but after some time, all this water with radioactive materials would go to the rivers and to the Kyrgyz region, where the Kyrgyzstan and Tajikistan and Uzbekistan, so transboundary problems would be very, very severe. That's why the problem was addressed very strongly in latest years, maybe 3 years. Okay. Safety is concerned with both radiation risks under normal circumstances and radiation risks at consequences of incidents. So here we speak about both situations. And here we have about nuclear reactor core, nuclear chain reaction, radioactive sources, and any other source of radiation. We embrace everything again. Another definition is from the federal law of the Russian Federation on environmental protection. This law was originally approved in 2002, but almost every year it had new additions. And here is the environmental safety, this state of, again, protection of the natural environment and vital human interests from the possible negative impact of economic and other activities, natural and man-made emergencies and their consequences. Yeah.
I think first definition that I didn't like to take it is mostly define radiation safety.
Yes.
And the one that the Russian definition is like general.
Yeah,
safety, right?
yeah, sure. But it also includes the radiation issues.
You mean the Russian?
Yeah, yeah. Because in this, I'm not sure if it is in English, but it has some clauses about radiation. You're right, it's general about environmental protection. Another publication, maybe you're familiar with it, the 8 fundamental safety principles. No? You know, you are okay, from very different organizations, from different countries, and I can understand that, say, in my professional activity, I don't know about very many important things. Not because I am ignorant, but just because I don't deal with that. that's fine. But anyway, this is a kind of fundamental issue, and I would advise you to just to maybe look at it if you have time. Because you know, just a step to the side. I understood during our training activity, my training activity since 2014, of Central Asia, that almost all people who had trainings in our academy have a kind of promotion after they came back. Not because they're so good, we ourselves, but there was an international status of this training program. I certificate, and it's very useful just to, for a short time, go up over your routine issues and have a wide view, broader view. It's really important for your professional activity. So, the fundamental safety objective. Again, protect safety and protect. Protect people and their environment from harmful effect of ionizing radiation. What can we do about it? Measures to control the radiation exposure of people and release of radioactive materials to the environment. That's the most important thing. Restrict the likelihood of events that lead to a loss of control over any source of radiation. And if something happened, we must mitigate the consequences. Now, just a briefly about this principle. Responsibility for safety. Somebody should be responsible in any case. There should be a person or organization who is responsible, officially. And principle 2 and principle 3 are very close with the role of government and leadership and management for safety. In most cases, the government is the government's took leadership for this issue because it's very important for the country or for a certain region or group of countries. Justification of facilities and activities. So here, speaking about the remediation, okay, just imagine the situation. You have a place with very serious, very high level of contamination. And you must decide whether remediate it or not. Your decision will mean that you either put some financial and other resources to this problem or not, or put them somewhere else. And for many countries, this issue is very, very important because resources, especially financial ones, are always restricted. So you begin thinking about what justification. Say you have 5,000 persons in this place, somewhere high in the mountains. You have different options. Either you clean the territory, remediate it, and there will be maybe more people, maybe there will be some tourist activity or something that will give at least some of your money back. Or maybe you just suggest to relocate these people to somewhere and let this situation be for future generations. No people and no impact. So it's a very important thing because I know in some countries, local population used such a situation and demanded much money for the relocation, demanded to relocate them to a capital, to give them flats or houses, to give them job, and those kind of political issues, very important. Okay, optimization of protection. It's almost about the same. You must think how to optimize the protection, not paying too much for it. Limitation of risk to individuals. This is understandable, and this mechanism is very clear. You have personal devices to register the, say, exposure, level of exposure. Protection of present and future generation. It's kind of political slogan, but anyway, we should think about future generation too. Prevention of accidents and emergency preparedness and response. Very close things. So you must think how, what kind of accidents you can have at your site of object, and think how to develop the emergency preparedness and response. This mechanism is very say it is developed in a proper way on the nuclear power plants, as far as I know in Russia, yes. And protective actions to reduce existing unregulated radiation risks. This is for uranium legacy sites, for sure. Okay, ensuring environmental safety on remediation at uranium legacy sites, ULS. It's an abbreviation of the acronym. Okay, about the remediation. For my opinion, I like this definition more than our national one, because this is the essence of remediation. Any measures that may carry out to reduce the radiation exposure due to existing contamination of land areas through actions applied to the contamination itself, the source or to the exposure pathways through fuels. You can see two ways. Yes. First, contamination. You can remove it somewhere. Say in Kyrgyzstan, in Minkush, what they did, they took the materials, radioactively contaminated materials from one tailing. Then they constructed the road to another tailing, high in the mountains and without flooding danger, and relocate all the materials over there, made a covering over it, and let it there. No people, a very low exposure, level of exposure, so let it be there. And the Tuyuksu tailing, where the material was taken from, just stay safe. But here they, for some reason, maybe political ones, they didn't demonstrate the third way. Again, the first is you remove or cover the source of contamination. If you remove this first one, if you cover, you close the exposure pathway. But there is the third way. What? You can either isolate the source from people, or isolate people or remove people from the source. Relocation. But they didn't, again, we at the IE meetings, we spoke about this issue, but again, politically, it's not accepted very often because of violation of human rights. And you need the agreement from all persons, and very often it's just impossible.
So, I mean, which one is not really acceptable?
So,
which you say that there are two ways: to remove the source or to isolate
you can remove the source. Either you can put something over it and just cut the pathway for exposure, coating or covering of the image.
I mean, after all, the third one you stated isolation of the source or isolation people from the source.
Isolate. I would say relocation people from another place. Something it's more sound economical.
Okay.
But it can be dangerous politically.
Okay.
In Kyrgyzstan, it was just the same situation because people, women with children, came to the roads, just cut the movement and demanded to do something. But they just wouldn't want to go somewhere, or wanted a lot of money. Okay, saying Russian national standards, another definition for another purposes maybe. Set of measures aimed at restoring lost quality conditions of land sufficient for the use in accordance with the intended purpose. So land reclamation, and again, this is more general, and it includes also not related factors. Here, as far as I remember, this is a situation in Tuyuksu. This picture was taken by the European Committee in early 1990s, and this one was taken in early 2000s. And you can see this is the path for water. the tailing was in the lower plains, and they took water around this place in this path. And by early 90s, it was ruined almost completely. I was there in 2007, and there's an awful situation. There's cattle grazing on radioactive lands. I saw how people took water, radioactively contaminated, and used it for irrigation. But now the situation is very bad. Sorry. Here, one more thing about safety, which is very important, is the end state. If you see the IE website or see any surface IE resources also, there are special attention to the definition or determinate the end state for any project. Because if you don't know the end state, the actually implementation of the project is impossible. You don't know where to stop. And which is more important, you don't know how you will report for spent money, especially if you spend it. So, what is the end state in general? A predetermined criterion defining the point at which a specific task or process is to be considered completed. So it's not absurd. You consider it completed. You put some conditions and you say that I think that at this point the work is completed and the project is implemented, realized. Used in relation to determination, this is the final status of a site at the end of activities for remediation, including approval of the radiological and physical conditions of the site and related structures. And another definition, end state after the completion of recultivation. This is Russian. Not remediation, no this term in our official legislation. Recultivation, state of the territory specified by the recultivation project. Again, we specify it by ourselves, depending on our purposes and on our resources, in which the area's characteristics after the completion of recultivation meet the safety criteria defined again in the recultivation project. So, how you can decide about this? How you can determine this criteria? Just imagine you have a necessity to make something in your own flat or house, and you must decide where to stop. How do you decide? What do you use? Because you know this repairing in a flat house is endless process. You can do it all your life, but you must decide where to stop. So you actually if
we can use it for intended purposes.
intended purpose, but again, I can wish to live somewhere in Himalayan, for example, but I understand that it's unreal or something else. So when in real situation, first of all, you have some resources, restricted resources, and you must understand that you can spend so and so, not. And you have a kind of big brother. Say international organization or international recommendation. Yes. I told you about our training courses by intention, because the importance for our trainees is that the courses were adopted, approved internationally by the IAEA. So, and if you need to justify your activity, you can tell your boss or your government or anybody, here the international recommendation developed by many countries and approved, and I suggest to put them as a basis to develop this safety criteria. And here again, you know, in my training practice, it's a very usual thing when a very curious and assistant training asks me, and why do you say so and so? And it's not a question for me, it's a question for our legislators, for our government. Here, look, they put this and this and this. So take this and go there. Don't ask me about it. It just puts out. What factors affect the determination of the end state? Again, a lot of them. We already spoke about financial resources. We know about economic, social, and cultural factors. Again, example from Kyrgyzstan. Regulatory basis, framework. Options of waste management, maybe it's just another level, not so general. Technologies, technological issues are very important. You must understand what technologies you can use, and maybe you just have no enough resources to buy these technologies and to buy equipment. And state and future use of the site. And stakeholder engagement. We'll speak about this a little later. It's a very, very interesting issue. I think that this issue is somewhere in between science and and something just unexplainable. You can only feel it. Determination of environmental remediation criteria. This is a picture of Minkush. This is processing plant for uranium ore in 2017. Again, remediation criteria are necessary for. Again, by the way, instead of word remediation, you can put another word connected to your professional activity. So criteria, determination requirements, determination of activities and priorities in these activities. The first, second, third, etc. And goals. By the way, I thought that maybe goals could be go to the upper level. But then I think that you cannot put the goal if you don't understand what are you going to do and what you can do. Because goal is maybe more specific. The basis for criteria. Standards, international ones for the first time. Taking into account the influence of factors on non-related nature. and assessment of integral risk, regulation framework, both international and national, and again, availability of resources. Maybe this thing unofficially can be on the first place. Our trainees, our colleagues from Central Asia very often told us that, great, fine, the IA recommendations are very good, but we cannot use them in our conditions, at least for full scale. It's impossible, because we just have another national traditions, another, all things are different, yes. So you can, you must use international recommendations, but you must think very thorough, think about your real conditions at the present time. What is good and what is not good. We say we have this situation in Russia in the 90s when many persons from rich families went for trainees to London, to the USA, to England, to Germany, then came here and tried to put management systems on this ground. Okay, it is working, but not very quick. It's slow process, because we have different situations in many things. Okay, and parameters for defining criteria. There are common criteria and site-specific. Sometimes they can be slightly different. And if you work with a specific site, you can take into account this specificity. Okay. Ensuring environmental safety stands for reducing the level of dangerous impact, both on environment and population, protection and restoration of natural environmental systems, which in many cases is impossible, speaking frankly, because you know, the real natural situation we won't be able to restore. Creation and development of operational information and analytical systems. Due to the great amount of information, we must have means to process this information very quickly and according to our purposes. And environmental education and enlightenment of population. You know, even here in Russia, say in Omnis, we have, maybe you, Omnis is a city in Kaluga region, about 100 kilometers to the southwest from Moscow. And there is a first nuclear power plant. Though in England, they say that Sellafield, that's not, it's kind of political. Again, and we have so-called trench, okay. No. Trench? Yes, yeah. And you know, in the early years of the existence of the power plant, they put this waste in wooden boxes, low level waste, and just done it. And then nobody knows what it said. You can only, it's just the same situation in Sellafield. I was there in 2016, just the same. One day, people from somewhere found out that a person, okay, dachas, you know, the small houses, they put some material from the road and put it on its roof. And it occurred to be radioactive. In Tajikistan, I spoke to one of our trainees, and he, that time he worked in a structure that was engaged in searching and looking for, okay, sources of radiation, okay, that have no own. How it's impossible? How it's possible? Somebody stole this thing somewhere, transported it, and then sell it, or just put it somewhere and forget it. So it's just a life situation, I guess. And here the environmental education and enlightenment of population that people who haven't higher education, they don't want to think about such things. They have a material, they need to build a house, and they just take and put it in the house. And radioactively or not, for them it doesn't matter because they don't know that. So it's a very important thing also. About the methods to ensure environmental safety. Managerial, state supervision, production control, and environmental management system. Again, it's a very complicated thing. I could speak about it for hours. No. Economic. Payments for negative impact on the environment and environmental fees and taxes. I think in your countries, you also have such things. That the company whose activity is harmful for the environment must pay for it. Technological. First of all, there's a best implementation of best available technologies. Informational, reporting and informing the population. Again, informing, educating and enlightening. And the legal method. Okay, this pictures Wismut, Germany, the place where uranium mining used to be. This is in 1991. I can understand that it's not quite clear for you. And this is in 20 years. They make a green place of it. You can do everything. You can live there, you can do what you like, but they put a lot of money. Germany is a rich country and they could afford it. Okay, reduce. Environmental means reduce the radiation hazard. And the general idea in the end, you can remove regulatory control from the territory, if it's possible. Sometimes it's not. But if you remove regulatory control, you can use this territory, the site, without any restrictions. The tasks are reducing existing radiation levels, reducing individual and collective doses, preventing the possibility of prolonged exposure in the future, and prevention or reduction on the environmental impact of radionuclides. What we are doing for it? First, we shall identify and give a quantitative description of the contaminated area, characterize it. And we should do it during all the project to understand if we are moving in the right direction. Then, establish remediation criteria. We just spoke about it. Then determination of the start date of remediation, select and approve optimized remediation strategy and plans and documentation. Then implement these activities and monitor the implementation regularly or constantly, which is there. When we finish, then we should provide verification of compliance with all final safety conditions we established before. Then follow removal of regulatory control from the territory. And restrictions maybe, or we shall continue control. Anyway, we shall do it. Because there are some cases, say in Kazakhstan also, again in 90s, when remediation was completed, there the site was abandoned, and local population, or not only local, took metal construction, took something and sell it somewhere. And that's all. No use of spending the resources. Okay. States of the territories after remediation. We can have either unlimited use. Do what you like. Parks, habitat, anything. Use with restrictions. Only industrial areas where people stay just for some time. And sometimes, if serious residual contamination after remediation is still present, you have restricted access area, fencing, and all the things. Sometimes it's just not, no sense to spend your money for your access. Okay. Again, radiation-contaminated areas. We need safety for these places. And here we concentrated only on tailing dumps, but we have also dumps of balance and off-balance ores, waste from leaching process, polluted territories of industrial sites, including the NOMS, naturally occurred radioactive materials, and not liquidated or not preserved, conserved mining methods. This is the USA, New Mexico. Okay, to be brief, we have about 2 minutes, yes, before we break. Am I right? I look at this watch, and we have 11:15. Yes. Okay. So, danger of tailings. 3 main things. First of all, tailings danger can be for environment and for human beings. Again, I told you about what I saw by myself. Drinking water supply, I mean in Kyrgyzstan, polluted water for irrigation, inhalation of dust. By the way, in Kazakhstan, in the west part, there's a lake. Yes, you know about. And use of contaminated plant products of agriculture and cattle grazing. All this is real, all this should be avoided. So, recommendation, I won't tell about it much. Measures to prevent filtration and dusting, 2 the most important dangers. So, You should think about it when designing the project. You should think about it when you locate the place, say in strategic master plans. Master plan for Central Asia, there's an international document. There were determined several sites of the priority importance. And some sites were just put aside for some time. What should you do? Remove vegetation from the tailing. Remove and preserve soil layers for future restoration. And create all construction to prevent leaking from this site. Okay. And another thing, just 2 minutes. Example of other tools for ensuring tailing safety. Do you hear about the environmental impact assessment? No? I think that radiochemistry is a very important tool for this thing. Actually, we have two things. In Russia, we have only this environmental impact assessment, but in many countries, say, including Nigeria, of course, Germany and Belarus and Mongolia, as far as I know, the USA, they have a tool of high level, strategic environmental assessment. This is for specific site. And strategic environmental assessment. We have some pilot projects, international projects in Russia, mostly in Siberia, about this issue. But if you have time or have a wish, I would suggest you to get know with this mechanism. So SEA, Strategic Environmental Assessment, and Environmental Impact Assessment. Very interesting international tools. Okay, and the second thing is the monitoring of the state of the territory, which is very habitual way for dangerous place. Okay. This is, okay, phone is not, I think, useful, but this is my office mail. So if you are interested in any issues connected to environmental safety, I will be glad to help you if I can. Thank you. Have a great day. I think we'll have 15 minutes according to the schedule, and we'll start 25 minutes to 12. Okay.
Cannot go in, cannot use it. Yeah. One. Yeah. You said immigration section has access area, so it means that you cannot go in, cannot do it.
If you have no specific purpose and specific permission, so for general public, it is closed. And maybe
the general public access.
Yeah. Because it's first of all it's dangerous, and the second it's useless. So it's better just to avoid going there. But you know, I didn't put these pictures. Say in Minkush, I saw we all saw fences broken with a lot of sheep or a lot of cattle on the contaminated area. So one thing is the rule, and the second how you can.
But they can do one of the remediation.
No.
So I think it makes it.
No. But it's just okay. I was in Oak Ridge, Tennessee, yes, and okay, it's sister city homes, and they have a big establishment for processing uranium ore, and now they put some a kind of industrial park with a lot of companies, small companies, but they are restricted to the kind of type of production. They can
allowed to produce something.
Yeah, and you have a permission to go. Okay, anyway. So
Shortly can be used, but with some
and actually, if a site is big, you can have some places with restricted use, some places with restricted access. So it's something.
Okay. So what about the radioactive that should have some measurements in areas?
Actually, as far as I remember, the total dose, and I'm not concentrating on myself, should be no more than 1 millisievert per year. From all kinds of chemicals, and these measurements, these data are in IA recommendations, so you can find them. No, it's okay. See, the Declaration saying, in Kyrgyzstan, they have, say, here is a tailor, and here is slide that is going down, and here is a water, but it was taken over the tank. And the idea of the slide all there and give cover, but the water will concentrate here. And will subside, but say in Tajikistan, they have in Tabasha, they have another thing. They have clay or something, unpermittable rocks. And in this case, you can just have the same, and leaking is just not possible because of the properties of the rock. So if you have some tailors here, you can put different layers, protective layers. You can put some vegetation here, and you will have not maybe green layer, but for restricted use. It actually depends also on the meteorological condition. If you have no almost no precipitations, and you know that it will be not this case, but water anyway will be no water. So your choice of technology will depend on the conditions.
This is just they changed the regulation, and I think there is some restriction.
When you say ecology, because I was So I provided, but I have the similar lessons.
Just you can find this.
Can hold this subject already. That is accepted.
You need to write it.
That is accepted. Can hold this so they also have the similar process. Ionized radiation accepted. What are the parameters here? We only define because there are two terminology. There is synonym of ecology and there are synonym of terminology.
Environment.
Yes.
You see, for my perception, ecology just more for science, and environment is just what all around us. Yes, but ecological, environmental, kind of thing.
Yes. So which parameters we are taking, like let's say industrial areas or public access areas. What about aerosols? What about the water, groundwater? Because we describe about the nature, about the past, but what's about the groundwater contamination? What about the aerosol contamination? What's about the project monitoring? We have to take the background study. For example, the area is earthquake area, the area is an ocean coast, tsunami sensitive area, like because we are from India, we have a purpose that is the ocean. So and there are places where the ocean is trying to build fast reactors in India. There are situations which are earthquake prone areas. So, but on the other hand, it is good for all possible other side for other purposes. It is good. But one problem is that it is earthquake sensitive area, earthquake prone area. So how to design the infrastructure so that earthquake or landslides like next natural hazards. India is a very it's a very good example where we experience all form of natural hazards. We have earthquake, we have tsunami, we have cyclone, we have earthquake. And then earthquake, then we have flood, then we have all these kind of issues of natural hazards. India has been experienced. So, what kind of strategy to be developed to the environment?
No, it's a very complicated and actually big question. I would say that. First of all, we must, let's say, Americans think globally and act globally. Yes. So, think globally means in condition of a country, or maybe in condition of myself. Globally, I mean that I think about the city as a whole organism, and as part of a system, part of the system are neighboring cities and roads and other things. Yes, but when I want to act, I must decide first of all, again, importance. If I have situation when population is in danger, this is one decision. Yes, if I just want to make living conditions better, they're good, but I don't want to make them better. Another decision. So it's a very complicated, and speaking frankly, if I have a special purpose, I can use different mechanisms and different systems for assessment to prove my position.
Very good example of Germany.
This one.
Is it close to the?
As far as I know, yes. Oh, what place?
Berlin.
Oh.
Stuttgart and Berlin. The Berg Academy in Freiburg. I totally visited tribal, all mining activities. So, have you visited the site? Have you visited the site?
No.
It's a very good example.
You know, we have a very brilliant opportunity. I have a brilliant opportunity to participate in the IA mission in Kurdistan. Because actually, I'm a geographer. I graduated from the Moscow State University, Northeast Department, geographical. And okay, I'm an educator. So I'm not a graduate. This is good and necessary. Good because I have a broader view. Yeah.
Scientific understanding and
Yeah.
the example.
But practical experience. This thing I need from my colleagues. Practical ideas, and this is a kind of mutual enrichment. So your question is maybe much more philosophical. And if nevertheless, if try and answer, I would say that if you want once, you just take the international adopted approved recommendations. You take some standards, you take some measurement from them, some data, some limits, and you prove your position before your boss, your government, speaking that this is so, and then they can do it. So it is in start. Okay, the recommendation is this, but we have no resources to do it. Or another thing, we have too rare population there, and we have much more problems with more thick population. Yeah, and yeah, it's 5,000 people. But what do you know? We have 60 million. What do you know? So it's
Are you working or
no, almost 100 kilometers. Welcome.
you are living here or
No, almost.
if I want to visit you on your infrastructure, I am from Nepal.
Great.
So if I come to facility,
Almost.
so how can I make an arrangement? I communicate to you.
Oh, yeah, and I will find the persons who are in charge. So we have, our academy is a very interesting structure. We have several, not separate, but several different organizations with some inner regulations, not regulations,
So maybe I should write an email.
yeah, it's the best thing.
Or I have our mobile number.
Maybe email is better because I travel widely, so sometimes.
Email should be the first one.
Yeah, it's the best.
I will.
You have, I think, just welcome. We'll be glad to.
Because it's many things. Theory is very good. Now we got the theory. You have a critical visualization understanding.
Yeah, the key word right here, practical. So if we have a not general issue, a general question, but practical question, we have this at hand. We want to do to come to this outcome, to this result. What can we do? So I'm here. I want to be there, and this is my way. How to? Yeah.
Okay.
So it's an iterative process. Thank you. How do you like the weather? How do you like the weather in Moscow? Hot.
Cheese. The cheese is like
And where do you live? In different places. So
yeah.
a long way from there to here.
One hour. 5 hours.
Not good. And what about traffic jams? I used to work in Moscow for 12 years. I like the city, but I don't like traffic here. Where are you from? Egypt, right? Many people from Egypt in our academy. Oh, Egypt. So our academy, not our youth, but our academy prepared personnel for plant treatment. So, and my not friend, but person whom I know well, he's in Egypt now. With his family. How do you like to be here for the first time? Second, in Moscow. Do you like seriousness? You know, it's good you haven't been here, say in the early 90s. I live in Obvious, it's 100 kilometers from Moscow, Kaliberiki, and we have a sister city in USA. I have a lot of friends there. Oak Ridge, Tennessee. Maybe you heard about it. One of the city of Manhattan Project, USA. And we regularly took people from there, delegation from there, almost every year. And they say every year the situation is bad and bad and bad. Moscow in the early 90s. Very dark. Very bad, the roads. Okay. Where is Andrei? Алло, Андрей, а будьте добры, поставьте, пожалуйста, презентацию на вторую лекцию. Ага, спасибо. Не хочу копаться сама. Okay. Andrei will come and switch on the second lecture. And the second lecture, I can characterize it with one of the favorite words of Homer Simpson: boring. Actually, this it can be boring, but it's very useful. At least our trainees use it. And maybe you are familiar with these standards and with this mechanism. Did you hear about PMBOK standards? PMBOK. Project Management Book of Knowledge. This is American standard. Again, very boring. I understood it from the third time. I read it through 3 times. And after the third time, I start understanding the idea structure. But actually very useful. And what is very good for this standard, you can use it as a whole, use it partly, or don't use it at all. It's up to you, just take some things. When we worked with this environmental remediation activity, the general idea was to provide 4 courses about the basics of remediation, and then for the same persons, for the same trainers, provide 4 more topical. One of these topics was project management. And as there are a lot of standards for project management, we decided to discuss this with IA. And we decided that this PMBOK is the best thing. If you are familiar with the idea of project management standards, there are 2 general groups. One is waterfall standards. Very straight. You know where you are, you know the desirable outcome, and you know the steps. Because it's a thing that was done in many situations. Another thing connected with uncertainty, like inventing some new devices. You don't know what will you have in the end. You only know the quality or the characteristics maybe, but you don't know the image of this. So PMBOK was approved by IA, so I can tell that it's good because it was approved internationally for this idea and for stakeholders also. I lost it. So now we will speak about the mechanism applied to stakeholders. Do you think there is any difference between the terms stakeholder and interested party?
Yes.
What is the difference?
Stakeholders are kind of a part of the whole project. They invest something. They can influence the decisions. They must be taken into consideration for getting in this.
I see. So they invest.
Also a part of liability.
Invest and influence. Yes. Okay. You know, there are arguing even in the IA about these terms, interested parties and stakeholders. The general difference that stakeholders for some people perception shouldn't include local population because they don't invest, but they can influence. They can influence and influence very strongly. If we have time, I will tell you a very brief story from Brazil experience, told me by my IA partner. About the influence of the local population. So actually, you can use anything. Sometimes the IA prefer stakeholders, sometimes interested parties. For me, it's just the same. And again, it's situation. Sometimes local population will not influence. Sometimes not. Okay. Stakeholder management. Again, 3 words: involvement, engagement, and management. Management may be more, maybe worse, because it's about manipulating. Yes, not involved, not engaged, but if you involve and if you engage, you do it by certain mechanisms. So you manage anyway. To manage, you must plan these activities. So, what for? What's the purpose? Okay, identify people, groups, and organizations that may affect or may be affected by, again, environmental remediation project. Actually, by any project. Analyze their expectations and their impact. And develop management strategies. What is very interesting in this process, you should, okay, like a doctor, you should always put your finger on the pulse all the time. This doesn't mean you decided something and analyze something and it's okay for future. No, the situation will change all the time. The stakeholder management focuses on continuous communication with stakeholders to understand their needs and expectations. Addressing issues as they occur, not later. Managing conflicting interests, because different group of stakeholders always will have conflicts. And you need support from all in your project. Oh, sorry. Again, and fostering the stakeholder engagement in the project decision and activities. And these are the key words here: stakeholder satisfaction. If people are satisfied with what you are doing, they will be supportive in any way. The segments of your activities. Identify. Sometimes it's very easy. So if you have investors, they are stakeholders for sure. If you implement some activities that are under regulation, that national regulator will be your stakeholder. If you have in close future some elections, that politicians will be your stakeholders. If you would say right words. Okay. Plan stakeholder management. Development of management strategy for effective engagement throughout all the project life cycle. Manage. So you plan management, then you implement this plan. Communication and work with stakeholders to meet their needs, expectations, and respond to their problems as they arise. Promoting their engagement. And not only manage, but also control engagement. Monitor all the time, regularly or continuously, depends on the situation. And why this is important? Do you know the 3 or maybe any characteristics of project? What is a project? Again, very difficult to make definition for simple words.
You have an idea and you have to materialize it, or you have a problem, you have to solve it, or you have to do something for something and supporting the society. So there are many objectives as an input, and how to materialize the ideas to solve a problem or to support and solve or to have some interest, whatever.
Yeah.
And the whole process is management and materialization. So input idea, cause or idea, and then management, and then materialization, whole involved by a project.
So we have input is a very proper word. So we have something that can be nuclear power plant. It can be your article, or your book, or your dissertation, or something, anyway, or repairing your flat. Doesn't matter. So you have here input. So for nuclear power plant is be plutonium. Yes. Then you have output. So for your article for scientific journal, there will be your knowledge, your scientific leader, information, and here will be for nuclear power plant electricity and heat for your article and the publication. What is here we don't have, and it doesn't have for us ever so far. What we are doing, we transform input in output. By what?
Available resources.
We have here we have tools and techniques.
Yes, what we can.
If we be more precise, here we have an owner of this process, of this, and here we can put resources here or something. That's right. Or resources can be legislative, material, and it can be personal.
Finance.
Yeah. So, three main parts: something at the entrance, something at the on the exit, and something in between. And project have a beginning and the end. If you have some operational activity, this is not project. Say you bake bread. It's not project. It's a continuous process. You take some. Project is unique.
And not.
Unique. Anyway, your article is not the article of your friend. Project need time, resources, and if you try to balance, you always either have not enough time or have not enough resources, or as a rule, both. Okay, and all projects have stakeholders. Who are stakeholders will speak a little bit. They can affect the project and its results to different degree and in different ways. That again, complication, sophistication, a lot of very system that is difficult to understand very often. Because this situation is changing, interesting are changing. Ability of the project manager to identify the managed and stakeholder in a proper way can determine the success or failure of the project. Again, Brazilian example, I will tell you about it. Okay, 3 components of the management project, stakeholder management. Identify, plan management, manage engagement, and control engagement. Very simple for the first view, first slide. Again, inputs, as here, tools and techniques, and outputs. And again, I should tell you that this general idea is very good, but it doesn't mean that you should take this standard and just put it as it is. You should think about your own situation.
So excuse me. I think one we should add on previous slides. At the end there will be time bound assessment.
Assessment.
Yes. Time bound.
Okay. Now it's not my idea. Yes, it's still there. Identify. So again, identify first, plan management second, manage engagement the third, and control engagement the fourth. So we'll start with identifying stakeholders. Inputs. Project charter, the main document for the project. Procurement documents, sometimes not, independent of the character of the project. Enterprise environmental factor, we'll speak about it. And organizational process assets, we'll also speak about it a little bit. And output is what? Stakeholder register. You have a document for your stakeholders. Not only the only document. There will be a lot of such registers, changing regularly. And how you can transform inputs into outputs. First, stakeholder analysis, expert judgments, and meetings. Expert judgments and meetings are very common tools here through the whole center. And they are the same everywhere. So we'll speak about them only one time. Okay, what's the sense of the process? Identifying the stakeholders and analyzing and documenting. You know that sometimes much more important to report properly than to do the thing properly, unfortunately. At least I have this experience. When you do very well, but you can report and your boss says, wow, well done, but where is paper? How can I say something to my boss? The key benefit, identifying the appropriate focus for each stakeholder and group stakeholders. What is the most important in dealing with this group or this person? Okay, who are the project stakeholders? Active involvement. And stakeholder may be at different levels within the organization and out of the organization. And very critical, identify stakeholders early in the projects or phase of the project. Why? You know, when you make a decision, it is very important and very tricky to involve in this decision-making process as much people, influential people, as possible. If they approve your decision, or at least the decision you suggested to them, and they put their signature, this is their decision too, not only mine. So they will be supported anyway, because it's there. So early stage, not after you started. And again, diverse number of stakeholders, depending on the character of your project. Okay, project charter, project documents. What is enterprise environmental factors? Organizational structure and culture. It's understandable, yes? Governmental or industry standards and regulation. You are acting in a certain framework, regulated framework. And global, regional, or local trends. You have to follow them. Process assets, stakeholder register templates. In past activities, your organization or maybe you personally can do something like this. So you can have some information that can use for future. Lessons learned and registers from previous projects. So we will see these tools later, but we won't tell about them anymore. Is that understandable for you? Enterprise environment, what you have in your organization and around it, and assets. What kind of documentation, put it in this way, what kind of documentation you can use. Okay. So, systematic gathering and analyzing information about stakeholders. What are you interested in? Interested of stakeholders, their expectation and their possibility to influence. And also you should understand their interrelations and interdependence with other stakeholders. The following steps of analysis. Identify all potential stakeholders and relevant information for them. Analyze potential impact or support of stakeholders, or maybe potential benefit from them. And assess how key stakeholders are likely to react or respond in various situations. That's the prediction. There are a lot of classified models for this. Have you dealt with a stakeholder? No, it's a very interesting thing, really. Power, interest, and greed, power, influence, greed, influence, impact, greed, and I will just tell you an example. Say, we have a power, interest, and greed. Here's a power and influence. Interest. Power means the ability of a stakeholder to influence on your project. And interest is activity. It expresses the activity. So we have different stakeholder A, B, C, D, etc. And here you have 4 squares. This stakeholder, not very powerful, less powerful than B. Yes? But B also is more supportive. So you have to manage closely with stakeholder. He is influential and he is interested in your project. But at the same time, you have to keep satisfied the stakeholder A, because it's rather influential and somewhat interest. And if you will make more interested, it can be here. So your main task, you cannot make your stakeholders more influential, generally, but you can make them more supportive. So put them to the right. It's very, very easy thing. I know that Rosatom has this chat, this grid for its stakeholders, and I know that this grid is renewed regularly.
So, excuse me, but there are scenarios, the same story from Rosatom. People, the public, local public, they were not a part of stakeholder, but they are very, very influential.
Yes, so let's say, okay, that's the arguing about the terms and interested parties. For me, it's just, okay, if you start working with anybody, first thing you should do, it's, arrange your common understanding of the terms. What is this, and what is this, and what is this, and what is this? Otherwise, I had a very interesting situation in one of the nuclear power stations. I gave training courses on procurement system that time, and two persons from the power plant, they were just arguing about something, and they used the word of we call bidding application, and they arguing. Yes, just a moment. What is application for you? It's a paper you you put to outer, to external products. Yes, about the procurement. And you application, that means that I put some paper and give it to my boss that I need this and this. But the word is the same, application, but different sense, completely different. And they argue for about 10 minutes, but senseless. Completely. So again, situation. I wouldn't say that interested party is forever and stakeholder is forever. No, just how we defend ourselves. Expert judgment. You just ask people whom you trust. You think that they know about the situation, and you ask them questions in any way, in focus groups, individually, or just in, and you collect this information and process it, and just that's all. And meeting, just meetings. You're familiar with this tool for sure. This is unfortunately not very good picture. Couldn't find better. Stakeholder register. So, try to role first for you as a stakeholder. Contact information. Category. Supportive, resistant, neutral, interest, great interest, or green, not very great interest. Influence, the most interested and most influential. Expectations from you, from the project. And how do they want to take information from? Mail, telephone, or ordinary mail. So but please, name of the project manager, project phase. Phase 1, beginning of the project, and this middle of the project. The register can be different. You should always put your finger on the pulse. Okay. How we can plan stakeholder management? Again, inputs. Project management plan. We've done it on the previous stage. Stakeholder register. We got it on the previous stage. Enterprise environmental factors and organizational assets. We know about them already. What we want to have? Stakeholder management plan, of course. And project documents updates. After all these processes, we need to update our documents. What we do? Again, expert judgment and meeting, asking people and speaking between ourselves. Yeah? Mostly project team with invited guests. And analytical techniques. Expert judgment meeting. Okay. This one. Please pay attention on this table. It's very interesting, very useful. We have four categories of stakeholders. Unaware of project, just don't know nothing. Resistant, aware of your project, and they don't support for some reason. Neutral, doesn't matter what is going on with your project. Supportive and leading. Here, unaware, resistant, neutral, supportive, leading. And you can document this situation. Say you have stakeholder 1, 2, and 3. Stakeholder 1 is currently unaware, but you need him to be supportive. And you see the way from here to here is rather long, so you will have to put some efforts to have the desirable situation. Stakeholder 2, neutral, and you need him to be supportive. And the third one, currently supportive, and you need him to be supportive. Where is the priority? I think here. It's very easy. But you also have to, here we don't know about their position on the influence interest rate. Maybe this is the most important stakeholder. I don't know. Here the table doesn't show. But we see this can be done. By the way, I personally did this 2 times for my personal needs. It's interesting. It's really interesting. Okay, outputs. Stakeholder management plan. Okay, plan is the plan. So we don't speak about it more. Just a minute.
One moment.
Well, no
I'm sorry.
That's okay.
This on.
So, desired current engagement, we just saw it in the table. Scope and impact of changes to stakeholders, what we need to do with that. Interrelations and potential overlap between stakeholders. It's a complicated issue. Stakeholder communication requirement. Information to be distributed to stakeholders. Reason for the distribution of that information. When you should distributed, disseminated. Time frame and frequency for the distribution. And method for updating the stakeholder management plan. And here with documents, we have project schedule and stakeholder register. We will have to update those things. It is time. Okay. Manage stakeholder engagement. What we have here, again, very simple. Fine. Here we have inputs, plan, communications plan, change log, and organizational process assets. Issue log, output, change request, project management plan updates, document updates, and assets updates. And what we do here, communicate, we apply our interpersonal skills and management skills. Okay, very familiar, except for change log. It used to document changes that occurred during the project. You started and you didn't need change log that time, but now you need it. Changes and their impact on the project and risks are communicated to the appropriate stakeholders. You should keep them informed about your activity and about your project progress. Tools and techniques, communication methods. Again, very big topic, very complicated and very interesting, very special, specific. Interpersonal skills. Again, very interesting. Building trust, resolving conflict, active listening, overcoming resistance to change. You know, it's a kind of medical specialist, maybe.
This is very tough when we are in Russia. Communications. There will be never ever any communication which is complete and which has a clear meaning.
Yeah.
People tell in installment and in step by step. If you put your finger in your mouth, ask, then you can get the whole complete information.
You know, when I was in the USA for the first time, it was 1994, they asked me, my American friends, they asked me about what I think about Gorbachev. I told them that I cannot understand it because he is asked a very simple question, but his answer is very complicated, and I don't understand what he told. He said, "It's okay. He's a politician. It's just his business to be ununderstandable, but very very pleasant." For their mentality, it was okay, but for many people in Russia, I don't know what's the matter. Say yes or no. Okay. And management skills, again, very close to interpersonal. Facilitate consensus, influence people, negotiate, and modify organization behavior. Okay. So we are managing stakeholder engagement, but we also must understand are we successful or not. So we have we need to have some control mechanism. Yes, mechanism. So here we have as inputs plan, issue log, work performance data, and project documents. Very simple, just understandable documents. Here, work performance information, change request, project management plan updates, document updates, and asset updates. How we do it? Information management system, expert judgment and meetings. Again, expert judgments and meetings are everywhere. The key benefit of this project process is that it will maintain and even increase the efficiency and effectiveness of stakeholder engagement activities in the project. Okay, look at it. Okay, I wanted to tell you about practical tips of communication. So you saw it is boring. Sure. It is boring but useful. But
Very important part of
you can trust me. You can try it for some practical situations, and you'll find. By the way, this is PMBIK. I found it is in internet. Now they have 6th edition. I work with 5th, and I would suggest you, I would advise you to have it, this document at hand, at least. Okay, practical tips for communication. Again, very tricky things. You should provide stakeholders with information about the various stages of the project at the time of execution in absolutely minimal volumes. No excessive information, because every piece of information you go somewhere can be diverted. Again, when I was a project manager myself, with say, with American organization in 90s, when I tell something to media, then I open newspaper. Why? I didn't tell that. I didn't mean that. Since then, I just put something by myself, write down, and give it to them, and touch. No changes. So minimal information, only very reliable and very clear and understandable. Then the information for all stakeholders should be the same and disseminated at the same time. Stakeholder should be invited to a dialogue, and this is not hindrance. This is a helping. This will help you to have supportive stakeholders. Dialogue is very complicated. Something, it's not pleasant, but you need to communicate. Okay, the options of stakeholders, even wild options, should be taken into account. And if you disagree, you must explain why and find the common points. And all requests for information should be considered in a timely manner. So if a stakeholder asks you a question, you should immediately answer. if you need it to be supported. It is better to place the information related to risks in a broader context. For example, the real situation before remediation and desirable after. We shouldn't discuss the situation at all because it's senseless. It's very difficult to agree the terms as we talked about. So only practical issues where you can have some prudence. To overcome the difficulties associated with uncertainties, you can use the presentation of scenarios in the best case, as a rule, in the worst case. And if the information is provided by several independent entities, it's necessary to coordinate the activities, but it's not necessary to seek coordination of positions. Positions may be different, but activities must be coordinated. And about this one, about risks. You know, I haven't got this slide here, but there's a very different perception between perception of risks between general public and experts. You can speak about expert profession, and risk for them is just uncertainty. For general public, risk mostly is danger. So you should be very, very accurate about it. So 2 minutes about Brazilian. So just imagine a real case, a place in Brazil, and Brazil, and a company, that's an international company, is going to mine uranium. The population is neutral, and Brazil is a very religious country, Catholic, and one of the Catholic leaders came to chief manager of the company and asked him before some celebration, church celebration, and asked him about support, money. The management was maybe unexperienced, maybe a little stupid, but he was rude with this religious leader and rejected to make it. The next day, it was or maybe later this week, on the message, this leader told his people that they're people from Devil, they do very dangerous things, and it's absolutely unacceptable. It was on Sunday. On Monday, 2 cars with employees of this company, somebody shot them in the forest. Nobody perished, but they have to go back. And all works were stopped. And the situation was decided by this way. This manager was fired. The leadership of the company met this religious leader. So they have an agreement, and that's all. So this fired manager but just didn't think about the situation, about the influential stakeholder and not influential stakeholder. So, again, no email free, but it was from the. If you need any communication on issues, my spheres of professional interest, and I'm an educator. I can tell you, I'm not a practitioner. So, as I told you, I have a maybe not narrow view, not deep view, but I have broad view. I can compare different things. So, procurement system in nuclear industry, stakeholder engagement, environmental remediation, environmental safety, what else? Quality management, quality assessment, quality management, and else. So it was a pleasure to meet all of you. I see your eyes and you're interested. Unfortunately, we have not much time. When I prepared these presentations, I considered them as future materials for our course on environmental remediation. You know, the professional, small professional army can be deployed into a big army if you have a core. So it's just a core, and this presentation, each of them, will be for 2 days. So, sorry for very brief, very concentrated information, but I hope it will be useful. Thank you very much. And we'll try email. Hope to see you in Minsk or maybe in the IA if I were with this okay, coronavirus, or how do you call it in English?
COVID-19.
COVID-19, yeah. So before that, I was in the IA maybe 3-4 times a year for different meetings. Consultants, technical ones, but now only this. But anyway, we are going to represent. And it's very good that professional interests, at least in our sphere, in nuclear sphere, are more important than political issues. It's good. Okay, thank you very much. You have your dinner, lunch.
Спасибо большое.
Так мы с вами не поеду, я сейчас рвану.
Да, давайте как-то.
И двигаюсь. Просто интересно, так раз. Это что?
Ага.
Там позакрывали все, но зато
А это где получается? Там, где вот эти цветочные были все?
Нет, ну вот Брестской улице, там площадь Европы.
Ага.
И вот это такое. Очень хорошо кормят, но что-то обслуживают тогда. Ну, вкус любишь. На всякий случай.
Хорошо, да, это интересно, спасибо.
И еще там одно открытие, но я не был, авокадо-клуб.
То же самое.
Да, там другие животные всякие разные. Жена, дети там приверженцы.
Я слушаю, удовольствие.
Сейчас их найду, посмотрим.
Ничего, нормально. Пандемия, вот сейчас опять нам здесь напротив. Я хочу восстановить все возрождение правосудия. Да. Не пожалуйста, не будет. Сейчас настроиться. Да, это серьезно. Ладно, спасибо. Взаимно. Взаимно.
Спасибо. Wish you safe way home. After this long time. And how do you because
Maybe you can write your email here, so I can immediately write an email. So that your email.
They are sending. This is my personal.
Let's get started. Inbox. Okay, so
This is a private or
it is a private one. I have also subscribed, but I don't.
and
Or can I say the subject so that you can agree the next one?
just put it IRRS. International Regulatory School. Yeah,
IRS.
yeah. Then sure.
ISSR.
ISSR. Sorry. Yeah, sounds cool.
2021.
And there's so many difficulties with communication.
A lot, sir. A lot. A lot.
How we communicate themselves.
Oh, that is not marking assignments, but communication with the administration and the university is really ocean.
Original barracks.
Yeah.
All right. For a couple of days.
Yeah, that's for sure. So do you have dealing with any project? Jason?
Yes, we have project with our certain updates, my personal project. I would say.
Because I want to work in some real world project to expose, to use my knowledge as well as to expose experience international.
This project, this particular project, is for developing training tools and
So,
on environmental engagement, safety on training, and social acceptability of engagement.
so I wanted to really take part into it. It can be a mini job or part-time job, but main objective is to deal with real-time, real-world scenario-based problems. Training materials is also a part of that. I'm ready to also take part in this if it's a personal and
We'll see. I can, okay.
I don't want a competitive salary.
No.
My only objective is how to be a part of real world program. And preparing training material is very global concept.
Yeah.
And so it is a very good part for me.
You see. What I can suggest just for this course. For this course, I think we can.
I can send you my CV.
It can be interesting to have some view from your to say evaluation of stakeholders program according to their customers. So in some countries, most plastic is done. In some countries,
Where and private people
Yeah. So
finance matters.
yeah. So things like this, because to train people, say for patient, type group, type calculation. That's different.
Very diversified.
Yeah. No, I can understand. Exactly. And okay, just try to
I send
utilize.
I send the email.
Mhm.
After you go back to office, you can return back my email. Then we can see how can jointly. I can send you my CV so that you will have understanding my academic and research backgrounds.
Mhm.
Then maybe you can have a joint meeting.
Yeah.
We have a joint meeting. If you have any card, it's okay.
No, I'm not a public person, so I don't teach it.
So we can have a Zoom meeting or any kind of video meeting to understand how together we can.
So, from my side, I will send you just what I did. And maybe select something. That is project. And we'll see the situation. Yeah. In this story, right? Department of International Relations and Relations. I am here somewhere.
Any agency?
Yeah.
Nuclear energy agency.
No, agency. But this is department
Of IAEA.
and this is a waste technology section. Here is our academy. And here's our
I want to be a part of this academy in the long run. I don't want anything for a software. I want, and this is also my question. I do not want a software business. First thing, activities. First thing. Second thing, money is not my first priority. This is why I want a long-term things. Money is not my first priority, but of course I need money to survive. In Moscow, it's very expensive.
you know,
I can teach.
I don't but you see.
So I can teach. I can prepare scripts. I can be a part of the investigation. I can be because I have a geoscience background. We have geography and I have geophysics and mineral exploration and all. I will send you my CV. It's a very broad spectrum from underground mining up to the space. So this.
So
Yeah. Okay, this is going project.
So yeah.
What is here?
Okay.
Yes.
Here. That is price. This. And second take through our this. I hope they will be supported. They used to be before, and this is supported. Okay. So we actually have international program for
CIS countries. Yes.
Commonwealth of Independent States. So international program for remediation. formulation, most of the circulation.
Mhm.
And, it's the owner is the partner.
Mhm.
So if we can form a kind of international team of experts
Mhm.
for this project,
Mhm.
it can be interesting
For them,
for
and it will have a long run.
yeah,
Have a
for
long run.
the technical what do they call it? TC department,
Mhm.
preparation department
Mhm.
of the island. They can mind.
So, sir, you know all this organizational structure. You know our roles and activities. And now I am ready to be part of you.
Yeah.
You please put me in a way so that money should not be a constraint. At the same time, we will be very productive. That is my whole objective. I can send you my I can send you my CV.
You see, let's since 26 till 8. That is IB invitation. So it will be great to communicate during this.
26 is too far, sir. We can do a meeting tomorrow. We can make a meeting tomorrow. But no, one day. Tell me now, I can prepare tomorrow.
Just
Sir, tomorrow-
give me some information.
And tomorrow there is a trip to go to some places, but not to this radon because of corona. Radon is closed, so they will go to a touristic place. I will not go. I can do a meeting with you, but yes, yes, yes. So when
And for me, I think that
tomorrow at what time we can talk at least?
I think
I can send my CV today.
First of all, yes, we will be great. First of all, we would like to discuss this idea with yes, with this first of all, and then with this idea about the international team festival.
Yes, yes, yes.
And my partner, not yes, colleague, yes, senior colleague from IE, he wanted to organize a distant meeting during this week. During this week. Unfortunately, he did. So I must communicate and try to do something. So before we start something real, we should have support for this idea, for this, and this, and this. If this organization is supported, it will be supported. If supported will be wrong, it's okay. So far, my task is to inform about our situation. So as you understand the scope and the possible perspectives, future perspectives.
Okay, I send you my CV today tonight.
Okay.
And I will wait. There will be my phone number, personal number, so you can call me at any time.
Okay, and I will answer no later than today's 12, 14, no later than 14. Okay, okay. Because tomorrow I will send this.
Okay, okay. So 14th I will expect that. I already sent a test message. For edit working on the email. Tonight I will send my CV. And on 14th we will have I will expect a message from you or direct phone call. You can call me also directly, no problem.
Okay, you know, calling sometimes sometimes
Okay, email is okay. Okay, email is okay.
Yeah,
Email is fine.
yeah.
So to maintain a clarity.
One time, I started from this. Each time, I asked him about some open. There's a way of people from
Very problem.
yeah, that's hard. If you wouldn't want to be involved. But when we still for us, thankfully, except for
Be careful about such things, but I understand. So I expect comforting in
no, maybe tomorrow.
Okay.
Have a good time.
Yes. I presume a long-term futuristic approach. With reliability and clarity.
Education is very good.
Yes. With reliability and unclarity.
Thank you.
Yeah. Thank you. I should.
Привет, слушай, ну я коротко, я еще из аудитории не вышел, разговоры были. Вот, давайте мы поговорим где-нибудь здоровье, все нормально, но я так понимаю, что, скорее всего, я пойду на 3, на 2 я могу инвестиции. Ну, я попробую, тут же из Нермедика позвонили зачем-то, сейчас еще с ним надо связаться, буквально 15-20 минут назад. Ну, давай, да, я тебе тогда через звоню. Ну, давай, потом.
Goodbye. Thank you very much. Thank you.
Да, вот ипотечки, политики. Там вот давайте посмотрим. И, может быть, вы нам пару минут еще уделите. Обязательно. Вот, наверное. Да, можно вниз спускаться, там доска можно записать. А у вас нет презентации как есть? Да, презентации есть. Ну да. Да, мы специально поставили кондиционеры. Ой, кондиционеры, эти вентиляторы, я купил все, какие были. Да.
Если что, мы что-то можем двигать?
Да, конечно, конечно.
Термическая переработка. Стоит вместе сейчас?
Да, давайте, конечно, мы сейчас все подготовим, запустим, загрузим. Так, вот у нас микрофон есть.
Здесь переносной,
Да, можно подключаться. Можно так говорить, как вам удобно. Можно с микрофоном.
Ну, я подумал, здесь очень однозначно. Все слышат.
Ну, хорошо. Ну, хорошо.
Поставить все.
Да, давай смотрим сейчас.
Now yeah, we have.
Да, ну как там, вы уже доедаете? Хорошо, как раз там будет это. Слушай, ну завтра Степана не будет, так что выручать тепло мы будем мы с тобой. О, послезавтра. Это будет, а в среду его не будет. Что ж, среда тогда на нас. Ну, меня уже спрашивали, ребят, я им уже сказал. Да, я им сказал, почему, сказал, что все уезжают в разное время, вот, и кто-то остается на следующей школе, и мы решили, чтобы это не делать, не разбивать, как бы все тогда не... Вот, все, давай, тогда ждем вас. Так,
Так.
Все, вот это не надо?
Нет, это мои рабочие материалы. Подождите, это в PDF, да?
Это в PDF?
Нет, там кто-то есть. Да, там кто-то есть. Здравствуйте.
Добрый день.
Так.
Вот.
Да.
Все отлично.
Ну, все.
Да? Все. Так, она будет первая, да, получается?
Нет, сейчас будет транспортирование.
Ага.
После этого
I don't know my number. Yes, I have those, I have the number, but I have this is my phone. Yeah.
Смотрите, если нужен микрофон,
Okay, right. Yeah.
да, может так, ну, можно здесь. Да.
это то же самое, что да? Я просто свои распечатал, свои.
Да. Это указ. Это история, да. А вот так. Так, Владимир, да, еще есть, они еще содержатся.
Да, ну понял. Ну, если что, почему мы оставляем здесь?
Техническая академия, которая, я вот когда сейчас управляющим советом карточку, они говорят, что это техническая академия, Нет, мы сказали, те страны, мы сказали, во-первых, каждая страна, которая разрешена, вот, циклическое стране, где-то кто-то стали здесь в стране, у нас осталось, да, да, конечно, что у вас тоже этот год должен быть, соответственно, не через инспекцию. Don't worry.
Does it help?
Yes, too much. It's not so nice. Thank you. Yes, yes,
I don't want to say no. People are being thrown out. I also do.
I guess maybe you misunderstand. You know?
This is fine.
Здравствуйте, уважаемые коллеги.
Good afternoon, dear colleagues, dear friends.
Разрешите представиться.
Let me introduce myself.
Начальник цеха по перевозке радиоактивных отходов и механизации радиационных репетиционных работ ПГУ «Продон» Головин Александр.
I am from Radon, a Federal State Unitary Enterprise, and I'm head of radioactive waste transportation and mechanization department.
Тема нашей лекции – транспортирование радиоактивных отходов.
The topic of our lecture today is the transportation of radioactive waste.
Транспортирование радиоактивных отходов – это комплекс мероприятий, обеспечивающих перевозку радиоактивных отходов. Ну, давайте сокращенно РАО. Можем? Это комплекс мероприятий, обеспечивающих перевозку РАО автомобильным, железнодорожным, воздушным транспортом, судами речного и морского флота.
Transportation of radioactive waste is a complex of measures that ensure transportation of hazardous waste by road, rail, air transport, river, and sea transports.
Транспортирование осуществляется организациями, имеющими лицензию на такой вид деятельности.
Radioactive waste transportation is carried out only by organizations who have license for such type of works.
На такой вид деятельности в сертифицированных транспортных контейнерах
who possess the certified transport containers
на специально оборудованных транспортных средствах,
with the help of specially equipped vehicles,
на которые должны быть получены санитарно-эпидемиологические заключения.
Which has the existing sanitary and epidemiological certificates.
Перевозка РАО в Российской Федерации определяется следующими документами.
Transportation of radioactive waste in Russia is determined by the following legal documents.
Основными документами перевозки РАО, которыми мы пользуемся, это НП 05316, называется «Правила безопасности при транспортировании радиоактивных материалов».
The main of them is safety rules for transportation of radioactive materials.
Далее, НП 07311, «Правила физической защиты радиоактивных веществ и радиационных источников при их транспортировании».
And the other is the rules for the physical protection of radioactive substances and radiation sources during freight transportation.
Далее. Постановление правительства Российской Федерации 23 октября 1993 года 1090 о правилах дорожного движения.
And also the decree of the government of the Russian Federation on October 23rd, 1993 on the rules of the road regulations.
Далее. При перевозке радиоактивных материалов должны соблюдаться два основополагающих принципа.
Then transporting of radioactive waste, two main principles fundamental must be observed.
Это первое, защита здоровья людей, которые осуществляют перевозку радиоактивных отходов.
The first is protection of the staff health who carry out works of transportation.
А также обеспечение приемлемого уровня охраны окружающей среды.
And as well as ensuring an acceptable level of the environmental protection.
Ну и остановимся на том, что у нас вообще подразумевается под радиоактивными отходами. Согласно федеральному закону 170 ФЗ от 21 ноября 1991 года, радиоактивные отходы, сокращенно РАО, это ядерные материалы и радиоактивные вещества, дальнейшее использование которых не предусматривается.
So according to the federal law on the management of radioactive waste, the determination of radioactive waste is is that among them there are radioactive materials which further use is not which do not have the further use.
В настоящее время в России для классификации РАО применяется следующий федеральный закон от 11 июля 2011 года номер 190 об обращении с радиоактивными отходами и внесении изменений в отдельные законодательные акты Российской Федерации.
Currently, the federal law number 190 on the management of radioactive waste is also defined the classification of radioactive waste in Russia.
Он подразделяет РАО на удаляемые радиоактивные отходы и особые радиоактивные отходы.
According to it, the main classification is that radioactive waste are divided into disposed radioactive waste and special radioactive waste.
Итак, удаляемые радиоактивные отходы – это радиоактивные отходы, для которых риски, связанные с радиационным воздействием, иные риски, а также затраты, связанные с извлечением таких радиоактивных отходов из пункта хранения, последующим обращением с ними, в том числе захоронением, не превышают риски и затраты, связанные с захоронением таких радиоактивных отходов в месте их нахождения.
So the disposed radioactive waste category, it is radioactive waste for which the risks associated with radiation exposure, other risks as well as the cost associated with its retrieval from radioactive waste storage facility, its subsequent processing, including disposal, do not exceed the risks and costs associated with the disposal of such radioactive waste in the place of their temporary location.
Особые радиоактивные отходы – это радиоактивные отходы, для которых риски, связанные с радиационным воздействием, иные риски, а также затраты, связанные с извлечением таких радиоактивных отходов из пункта хранения, последующим обращением с ними, в том числе и захоронением, превышают риски и затраты, связанные с захоронением таких радиоактивных отходов в месте их нахождения.
As for special radioactive waste, the risks associated with radiation exposure and all the following steps of their handling and processing exceed the risk and cost associated with the disposal of such radioactive waste at place of their temporary storage.
Критерии классификации удаляемых радиоактивных отходов с учетом технологических особенностей обращения с радиоактивными отходами устанавливаются правительством Российской Федерации.
Criteria for classification of disposed radioactive waste are taken into account the technological features of its management, and they are established by the government of Russian Federation.
Радиоактивные отходы у нас делятся на три вида по своему агрегатному состоянию. Жидкие, твердые, газообразные.
The stated matter radioactive waste are divided into three categories of liquid, solids, and gases.
Радиоактивные отходы, так, твердые, жидкие, газообразные, к жидким радиоактивным отходам относятся не подлежащие дальнейшему использованию органические и неорганические жидкости, сульфы и шламы.
As liquid radioactive waste, we consider organic and inorganic liquids, props and slurs that are not subject for further use.
К твердым радиоактивным отходам относятся отработавшие свой ресурс радионуклидные источники, не предназначенные для дальнейшего использования, материалы, изделия, оборудование, биологические объекты, грунт, а также отвержденные жидкие радиоактивные отходы.
As for solid radioactive waste, it includes spent radionuclide sources, materials, products, equipment, biological objects, soil, and solidified liquid waste, which are not intended to further use.
К газообразным радиоактивным отходам относятся не подлежащие использованию газообразные смеси, содержащие радиоактивные газы или аэрозоли, образующиеся при производственных процессах.
As for gases radioactive waste, we consider non-residential gases mixtures containing radioactive gases and aerosols.
Для предварительной сортировки твердых отходов рекомендуется использование критериев по мощности дозы гамма-излучения на расстоянии 0,1 метра от поверхности. То есть низкоактивные от 1 микрозиверта до 0,3 миллизиверта, среднеактивные от 0,3 до 10 миллизивертов и высокоактивные больше 10 миллизивертов.
For preliminary sorting of solid waste, it is recommended to use criteria for gamma dose rate at a distance of 10 centimeters from the surface. And the classification which you can see now on this slide determines this level.
В Российской Федерации для классификации упаковки для РАУ используется документ НП-05316, называется он «Правила безопасности при транспортировании радиоактивных материалов».
The main requirements for the transport containers are determined in safety rules for transportation of radioactive materials.
Данный документ у нас классифицирует упаковки. Упаковки могут быть согласно НП-05316, классификация упаковочной тары у нас может быть освобожденная упаковка, промышленная упаковка, упаковка типа А, упаковка типа Б и БУ, БМ и упаковка тип С.
According to this regulation document, there are several types of these certified packages for radioactive materials. Among them, there is an exempt packaging, industrial packaging of 3 types, and packages of A, B, and C types.
Конструкция упаковки должна быть такой, чтобы с ней можно было производить простые операции при перевозке, то есть погрузка, разгрузка без сложности и риска.
For all type of packaging, a special feature is a certain design that corresponds to the characteristics of the transported materials as well as fair weight.
Надежность элементов крепления на упаковке при перемещении упаковки.
Also, the objective is the durability of fasten elements of the package.
Важно отсутствие выступающих элементов на упаковке.
Also, it is important not to have any elements on the surface of the package that can be as protruding elements.
Так, не должны присутствовать какие-либо посторонние элементы на упаковке, которые могут как-то помешать при транспортировании.
Also, the package should not consist of the elements which can somehow interfere the process of transportation.
Все элементы упаковки и крепления должны быть химически совместимы.
And of course, the material of the package and the elements and the fasteners must be chemically compatible.
Содержимое упаковок должно соответствовать типу упаковок.
And the content of the package must correspond to the type of the package.
Продом в своей повседневной деятельности использует следующие виды упаковок, контейнеров.
In the daily activity of transport operations at radio company, the following types of packages are used. Oh, also the variety of packaging types. The containers with a large volume.
Автотранспорт. Разберем с вами следующий вопрос. Автотранспорт предназначен для перевозки радиоактивных отходов.
The vehicles which are intended for the radioactive waste transportation.
В Российской Федерации при перевозке РАО чаще всего используются грузовые автомобили, модернизированные под перевозку радиоактивных отходов.
In most cases, for radioactive waste transportation, the modernized trucks are used.
В конструкции данного автомобиля заложен специальный контейнер для перевозки радиоактивных отходов.
The main element of such vehicle is a special container for radioactive waste transportation, which is designed, which must be designed for this purpose.
В данном случае мы покажем на фотографии. Такой контейнер обладает необходимой механической прочностью, герметичностью, радиационной и термостойкостью. В его конструкции предусмотрены механизации процессов разгрузки и выгрузки упаковок с РАО.
So there are demands of the mechanical strength, of tightness, of radiation, heat resistance, and the design of the modernized vehicle should provide the possibility of mechanization of the process of loading and uploading of packages with radioactive waste. Also, the truck, the body of the truck is made of stainless steel, and another obligatory thing in the design of vehicle for transportation is the presence of lead screen between the truck body and the cab.
Далее, в общем случае для перевозки РАО должен использоваться исключительно специализированный транспорт, который соответствует всем соответствующим нормативным документам российского законодательства.
The truck for radioactive waste transportation must meet all the requirements of the legislative documents.
Требования к техническому транспорту, перевозящему именно РАО, а не какие-либо другие опасные грузы, имеют некоторые послабления, поскольку главный акцент в обеспечении безопасности при перевозке РАО заложен все-таки не в сам автомобиль, а прежде всего в упаковку, то есть качество изготовления самой упаковки, в которой находится РАО.
Although there are requirements for technical transport for dangerous and hazardous goods transportation, is almost the same as for radioactive waste transportation. There is a concession because the main thing for ensuring safety during transportation of radioactive waste is the package and the quality and the possibility of this package to ensure safety during transportation is the main thing. And it can prevent all types of external influences.
На слайдах предоставлен транспорт, в котором работает осуществляет перевозку. Мы показали первый автомобиль, а еще каким транспортом мы перевозим.
So these slides they show the different types of vehicles, the modified trucks which we use during radioactive waste transportation works.
Здесь представлен комплекс для перевозки жидких.
Here is presented the truck for transportation of liquid radioactive waste.
То есть данный автомобиль — это модульная система, он может перевозить жидкие радиоактивные отходы, съемный модуль может перевозить твердые радиоактивные отходы.
This vehicle is has modular system and is intended for transportation as liquid radioactive waste and at the same and also for solid radioactive waste because the models on the truck body can be changed.
Так, а теперь мы с вами более конкретно рассмотрим сам процесс организации перевозки РАО. Ну, берем применительно к нашему предприятию.
Now we will examine the whole process of radioactive waste transportation as it is carried out at our company.
Значит, сам весь процесс. Первое, для того, чтобы организация могла перевозить радиоактивные отходы, она получает разрешение на перевозку радиоактивных отходов. Разрешение российского образца представлено на слайде. То есть
the first thing necessary to transport radioactive waste it is the receiving of the permission for radioactive waste transportation and the example of such a document is presented on this in figures 1 and 2.
Далее, для того, чтобы перевести РАО, заказчик, ну то есть какой-то организации потребовалась необходимость перевести радиоактивные отходы, то бишь избавиться от них, они заключают договор. Ну, повторяюсь, мы рассматриваем нашу организацию.
The producer of radioactive waste should make a contract for radioactive waste transportation with the specialized organization.
Заключается договор, есть. Далее, в перевозке радиоактивных отходов участвует высококвалифицированный персонал, то бишь первое лицо – это водители. У водителя у нас должно быть первое – это водительское удостоверение, далее свидетельство ДОПОВ о подготовке, что водитель прошел обучение, может перевозить опасные грузы, и карта тахографа водителя. Ну, здесь, так как мы в России, российского образца, то есть, согласно этой карта идет учет его времени, режим труда и отдыха водителя. И сам...
The company who carry out transportation of waste must have specially trained personnel, staff, and the driver. The driver has the following documents. First of all, driving license, of course. Also, it is the provenance of the ADR permission and also the electronic card for each driver, which is connected with the system, which during the work of the driver determine the periods of his work and the periods of rest.
Далее, специалист у нас подготовлен. Следующее. Идет выбор и согласование всего маршрута, по которому будет проводиться, осуществляться перевозка РАО.
The companies who provide transportation also determine the road of the ready-to-waste transportation and provide its I'm sorry. The road of the ready-to-waste transportation is must be considered with their all regulation organizations.
Далее, перед перевозкой, как правило, за день до отправки происходит входной контроль, традиционный контроль упаковки работникам организации перевозчика.
Also, at the next stage is the duty of the driver to accept the waste from the customer and to make the examination of the waste and to make the examination of the waste.
Следующим этапом у нас является, когда водитель прибывает на объект, он принимает от заказчика груз, согласно рисунок 5, товарная накладная, принимает для перевозки.
He's presented the example of the document which the driver which the driver receives from the waste producer company and check the accompanying documentation, technical agreement for the performance of work, and documentation with the conditions for ready-to-waste transfer to the specialized organization.
При транспортировании автомобильным транспортом погрузка РАО производится таким образом, чтобы мощность дозы излучения в воздухе в кабине спецавтомобиля была минимальной, но не более 0,12 миллизиверт в час.
The main thing when the packages of waste is already loaded inside the truck is not to exceed the dose rate from the cargo to the place of the driver, and in the cab of the vehicle it must not exceed more than 12 microsieverts per hour.
Мощность дозы излучения в любой точке с наружности поверхности кузова спецавтомобиля не должна превышать 2 миллизиверт в час.
And the radiation dose rated in point from the outer surface of the body of the special vehicle should not exceed 2 millisieverts per hour.
Мощность дозы излучения на расстоянии 2 метров от внешней поверхности спецавтомобиля не должна превышать 0,1 миллизиверт в час.
And the radiation dose rated to a distance of 2 meters from the external surface of the special vehicle should not exceed 0.1 millisievert per hour.
Традиционный контроль в процессе загрузки пути исследования осуществляет дозиметрист. Ну, у нас это водитель-дозиметрист.
Radiation monitoring during loading and on the road of the special vehicle is carried out by the dosimetrist driver or a person who accompanying the cargo.
Так, после чего пломбируете кузов автомобиля в случае.
After that, the body of the truck is sealed by the waste producer representative.
В случае выявления ошибок при оформлении документов или превышения уровня излучения,
In case of violations in documents preparation or when the dose rate from waste exceeds the figures which were initially fixed by the waste producer,
водитель обязан составить акт регистрации нарушения, акт регистрации нарушения.
In this case, the driver make a special registration of such a violation and do not receive the radioactive waste for further transportation.
В данном случае возможность перевозки РАУ сводится на нет, то есть до устранения нарушений.
And before the violations are eliminated, this cargo is not intended for transportation.
Далее, когда автомобиль у нас загружен, на автомобиль, согласно ДОПОК, вывешиваются таблички. Когда автомобиль загружен, согласно ДОПОК, на автомобиле вывешивается специальная маркировка.
When the truck is loaded, according to the demands of the regulation body, the special sign is placed on the surface of the truck body.
Так как радиоактивные отходы являются опасным грузом 7-го класса,
This special marking indicates the class of danger according to dangerous goods demands of transportation.
Прибытие на предприятие, разгрузка и передача РАО происходит в обязательном присутствии водителя и дозиметриста.
When the cargo with radioactive waste is coming to the specialized organization, its receiving is carried out in presence of the driver and according to the developed procedures of waste receiving.
Так, значит, в результате мы имеем две стороны, участвующие в процессе перевозки радиоактивных отходов, обязанности, которые входят в определенные функции.
So, as for a conclusion, in the process of radioactive waste transportation, there are two main parties, sides.
Первым участником перевозки является клиент, юридическое лицо, которое выражает необходимость перевозки.
The first side is the waste producer, who has an intention of radioactive waste transferred to the specialized organization, disposal site.
Так, из пункта А в обязанность этого участника входит наличие всех документов на радиоактивные отходы.
And the main demands for this side is to have all the set of documents ready for transportation and filled in accordance with all their requirements.
Поскольку в случае отсутствия или несоответствия определенной нормы, перевозчик вправе отказать в перевозке радиоактивных отходов.
Because in case of the absence of such documents or violations in them, the transport company has the right to refuse to transport radioactive waste.
Вторым участником перевозки у нас является непосредственно компания-перевозчик.
And the second side of radioactive waste transportation is the specialized organization who provide transportation of radioactive waste.
которое больше всего представлено в процессе перевозки водителем экспедитором, потому что водитель один же все процессы осуществляет.
With the main representative of this company as the driver of the special vehicle and those driver those.
Который будет осуществлять главный процесс транспортировки, в ходе которой именно на нем будет лежать наибольшая ответственность за жизнь и здоровье окружающих людей, а также забота о сохранности и экологии в процессе транспортировки.
So the main responsibility during the transportation carry out the driver because he has this greatest responsibility for the life and health of the people around, as well as the concerns of as well as providing the safety of the environment.
Соответственно, на компании-перевозчике лежит наибольшее количество функций.
So the transport company has in this process the greatest amount of functions.
Отбор тары и упаковки для РАО, проверка на соответствие этой тары.
It is choosing the appropriate package for radioactive waste and checking its properties.
Входной контроль, который направлен на проверку того, что в принципе будет предметом перевозки, то есть шумоперевозки.
The input control, which check the consequence of the package with waste properties to the contract matter.
Проверка всей необходимой документации, которую обязан предоставить перевозки заказчик.
Checking all the necessary documentation which must provide the customer.
Проверка надежности креплений в транспорте, на котором будет осуществляться перевозка.
Checking of the durability of the fastenings elements with the help of which the package is fixed inside the truck.
Также уже, как мы говорили, в случае обнаружения соответствия документации водитель может составить акт и отложить перевозку до устранения.
And also in the case of violation, the driver is the person who can refuse transportation before the elimination of the violations which were, for example, found during the checking.
Ну, теперь вся перевозка осуществляется у нас, вернее, контроль всей перевозки осуществляется сотрудниками службы безопасности.
The transportation of radioactive waste when the vehicle is on the road is the control of it is carried out by the security service of the transport company. With the, by exchanging messages via communications and means using navigation tracking systems.
При возникновении нештатной ситуации водитель в любую минуту может связаться со службой безопасности.
So if the accidental event occurs, at the same time the driver has the possibility to communicate with the security service. So thank you very much for your attention, and I'm ready to answer any questions. Yes, please.
There was one level that you put on transport car.
shows some numbers. So what's the meaning of this number? Maybe you chose and I missed.
The orange ones.
Sorry.
The orange one.
700 kilograms.
Вопрос по поводу маркировки груза, вот это оранжевый.
Значит, государство,
знак, что там
которое...
значит цифры.
Цифры 7.0 это 7 класс. Дело в том, что... А? Дело в том, что не все страны входят в ДОПОК, Европейское соглашение.
Not all the countries are members of ADR.
Это согласно Европейского соглашения о перевозке опасных грузов.
And according to ADR agreement, when hazardous materials are being transported,
Не все страны входят в это соглашение, поэтому многие могут не знать. Значит, цифра – это обозначение 7 класс опасности.
The number 7 is the class of danger.
Здесь именно по упаковке, как везется груз освобожденный, это большая расшифровка. Это именно на сам груз, на упаковку.
And these numbers reflects the cargo itself.
Сейчас. Так, мы объяснили, это откуда вопрос, какая страна? Да? Но дело в том, что в этот доклад не все страны входят, не все могут это знать. И, допустим, я могу по стране, у которой не входит в эту организацию, я могу ехать, вести опасный груз вообще без знака.
So this marking is necessary for the transportation of hazardous waste according to European Agreement on the international carriage of dangerous goods by road. It shows the class of danger of the hazardous material which is being transferred, and also the numbers, the other numbers, they characterize the package itself.
So if I understand correctly, each number means a substance, like material.
То есть каждая цифра означает вещество.
Первое. Вот эта цифра обозначает, что мы везем радиоактивность. Да. Эта цифра обозначает 7 класс опасности. Здесь.
This number indicates the 7th class of danger.
Нижняя цифра это обозначает, в какой упаковке едет радиоактивное вещество. Оно может быть в коробках, может быть просто в контейнере насыпано. Ну, там большая таблица. То есть именно обозначает упаковку.
And these numbers, they indicate the type of package which is used for dangerous goods transportation.
А второй знак это знак опасности. То есть на автомобиле у нас вывешивается этот, или же вывешивается, и плюс вот этот знак, это знак опасности, обозначает, что автомобиль везет радиоактивный груз 7 класса опасности.
And the other marking shows that the vehicle transport radioactive waste, and according to hazardous materials, it has the 7th class of danger.
Но вторая цифра, мы уже сказали, это в какой упаковке. Может быть просто пустая упаковка из-под раунда, там другие цифры будут.
So, for example, here also by these figures, there is a special table where indicates the type of waste, or maybe that now the package is empty. So these table with numbers, it refers to the content of the transported material.
Ну и покажем живой автомобиль. Да, показывали, да. Ну вот как видите, да, вот автомобиль, вот реально автомобиль, который, вот на это лучше видно. Он оборудован, видите, да? Сзади.
So here this marking is placed in the end parts of the truck.
И вот видите, груз у него в бочках, у него цифры 29-15.
And for example, here
Все зависит от упаковки, в какой упаковке есть груз.
Here are placed drums, metal drums we placed, and they have this indication of 29-15.
Ну и, соответственно, автомобиль оборудован световыми сигналами для перевозки опасных грузов. Это видите, проблесковые маяки, ну, оранжевого цвета. Ну и, соответственно, документы водителя мы уже рассматривали. То, что должно быть у водителя. У водителя свидетельство ДОПОК, вот что он может перевозить опасные грузы. Это опять же по Европейскому соглашению.
ADR agreement also is determines that the driver has this special permission from according to the demands of ADR organization, European Agreement on International Carriage of Dangerous Goods by Road.
Ну, соответственно, также у водителя водительское удостоверение с соответствующими категориями на право управления данным транспортным средством.
The driving license includes the permission for special for this type of vehicle driving.
Ну и также, как уже повторяюсь, карта водителя, которая позволяет отслеживать режим труда и отдыха водителя.
And also the card of the driver, which make it possible to understand how much time does driver spend in a road spend for driving, and how much time the driver spend for the rest.
I have several questions. So first question is, the first one was, all this transportation process is national law or international law?
В соответствии с внутренним законодательством весь транспорт или с международным законодательством.
Это прошло.
Ну, то есть
whole transportation process.
Вот этот вот процесс транспортирования будет в соответствии с нашим законодательством и в соответствии с международным законодательством.
Значит, наше законодательство нам все расписывает, международно, мы только ДОПОК, используем ДОПОК, потому что это международное европейское, вот только его. Короче, наши документы внутренние российские и
Наши правила НП-53 соответствуют
МАГАТЭ, да? Ну вот наша 053-16 соответствует требованиям МАГАТЭ, и плюс ДОПОК, это опять же европейское соглашение.
So the national standards for transportation they are based on EAA documents, and also the process of radioactive waste transportation is carried out in accordance with this European Agreement on the International Carriage of Dangerous Goods by Road.
And the transportation vehicle you saw from Volvo, it's not from Russia, it's from Sweden. So do you have a special agreement with Swedish people, or with respect to vehicle art, or simply following IAEA recommendations?
Выбор марки автомобиля, который используется, например, Volvo, он на чем основан? Тоже на рекомендациях?
Надежность, безопасность.
So the choice of the mark of the vehicle is just because of its durability, because it is. But in any case, all these vehicles are manufactured in Russia.
Okay. The last question is, For example, on the way there is an accident happen. On the way there's an accident. Who will be liable for that incident?
Если во время происходит авария, то несет ответственность за
It follows national law or IA guidelines.
Во время транспортировки все
Who will
ответственности.
compensate and who will liable for that?
Кто в этом случае, там, допустим, финансирует ущерб?
Короче,
2011 law I saw, 2011 Gazette, Russian Federation, that doesn't incorporate accidental issues. In the second slide,
На втором слайде там было, что соответственно там
yes,
Yes.
2011, it's not incorporated accidental incident.
So will you repeat the question, the whole?
This gadget, federal law, is from Russia.
Yes, it
Okay,
is.
so with respect to this law, 2000
Соответственно,
gadget means federal law. 2011, what's about the accidental scenario? If there will be an accident on it on the way, who will compensate the casualties and who will be liable for it?
То есть в соответствии с этим документом распределяется ответственность, допустим, за аварию, если какая-то компенсация там за аварию с радиоактивными.
Ну, во-первых, мы составили штрафуется по перевозке.
Ну, что эти законы определяются.
У нас не совсем.
Вот у нас.
It's very important if it is a gaseous and there is a leakage happened.
То есть, например, если произошел разлив радиоактивных жидкостей или выброс газообразных отходов, то
So
есть
it is not fun. So there must be someone who will liable.
Кто несет
кто
ответственность?
несет ответственность за это, компенсирует вред.
Ну, во-первых, перевозчик все равно, мой предприятие несет ответственность. Плюс наши перевозки застрахованы. Мы непосредственно все равно мы осуществляем перевозку.
So all the responses on the company who make transportation, the relative waste during transportation, they have insurance and the insurance company pay for the possible harm of the accident.
So there are three parties. One is sending, one is transporting, and one is receiving.
Здесь, то есть, фактически получается три стороны. Одна, которая отправляет, вторая, которая перевозит, третья, которая принимает.
So who is this?
Кто в этом случае ответственный?
Та сторона, которая перевозит. Почему у нас возлагается ответственность на водителя, который уже взял этот груз? Он написал в накладной, принял перевозки, и во время перевозки все, мы уже, и наш представитель за сутки до этого побывал, принял груз для роддома.
So the responsible side in this case is the transportation company. Transportation, because they receive the cargo and it is their field of responsibility.
Как работа поставлена так, что вышел запрет,
As for our company, within the 60 years of its existing, there was no any accident.
Yes. Very good. But that we have to be always careful. We have a long-standing successful story. It doesn't mean we will be careless.
То есть, ну, как бы у них,
We have, for example, we have a long successful stories, long successful experience or history. That doesn't mean we will be careless, because Soyuz, how many times lost on its way. So Soyuz also have a long-standing history. I mean, where it crosses below the lower target several times. So the accident happens fraction of second.
Ну, то есть любое, ну, что они даже не застрахованы.
Это понятно, мы готовы. Но у нас есть для этого служба
One
радиационной
second,
безопасности.
just one is enough to destabilize and
Иногда, да,
destroy the
2 секунды достаточно, чтобы что-то произошло.
Ну, у нас в Грузии, во-первых, средняя место активности. Занимается нашей работой. Специально для
Это важно. Да, что у нас низкоактивные преимущественно, а упаковки Decontamination. А это редкость.
Кстати, упаковка степени, они большая запас прочности.
Just a second, I will answer the previous one. This principle of many barriers, it doesn't work. So the main thing it is transport container, which is intended for transportation, and the certification of this container includes the tests of its falling down of possible accidental events. And if this container has this certification, it can be it is the main barrier for the content of radioactive waste and the environment. And even in the case of accident, the container is the main element who provides the safety. Also, we deal only with low-level and intermediate-level waste.
Yes, that's the second point. Yes.
Жидкость оттуда переводится в точку, имеет двойную, ну, то есть двойную оболочку, там залита жидкость. В случае прорыва эта жидкость затягивает.
And if we speak about liquid waste transportation, the drums with waste, they are placed inside a special another drum with
Между ними состав специальный, который в случае, если лопнет оболочка, этот состав затягивает.
In this case, the vessel where liquid waste are placed, it has a special system which prevent the spread of liquid outside because of this system of pressure control.
The vehicle also matters. This is why we use a guidance navigation control system, GPS or GLONASS. We are using the system to monitor the trajectory and the path of the vehicle. If the truck is going with 90 or 80 km per hour speed and it make an accident, it's enough to destabilize the container. This is why we are monitoring by GPS or GLONASS any guidance and navigation system. So only container is not enough. If it is a speed, they have kinetic energy, then liquid container has this stability always. The solid waste has more stability compared to the liquid, because liquid has a different dynamic property with respect to kinetic energy. And 80 km, 90 km speed, any accident is enough to destabilize the container.
Скорость перевозки, конечно, например,
Согласно российского законодательства и правил дорожного скорости. У нас грузовику больше 90 нельзя.
And so the speed limits for
speed limit is there because kinetic energy always has an impact.
Yes, there are speed limits according to the rules of road movements, and it is limited by 90 kilometers per hour.
Exactly. If you go above that, it will be a problem.
So we ну, то есть все равно утверждают, что все-таки это юридическая скорость.
Ну, у нас нет таких специальных условий. Согласно правил дорожного движения.
So these limitations, they are made for these category of hazardous, dangerous material and are possible according to the requirements of the rules.
Thank you for your question.
Do you need to make transport safety and security plan during before transportation?
The company of transport.
I mean, do it
Transport plan security.
Plans. Safety plans?
Do you need yes, plans for transport?
Месторождение транспорта.
Ну, так как мы низкая активность отхода, нам сопровождение. У нас служба безопасности, машина GPS-12 оборудована, сидит диспетчер, есть защита, и наблюдает за машинами. И с водителем у него связь с радиостанцией.
So for transportation of low and intermediate level waste, the physical protection accompanied by road police, for example, is not need only for transportation of waste with high activity. But in our case, the process of transportation is under control of the security department, who on the screen see the movement of the vehicle and can, and in case of something, he has the ability to communicate with the road police or other.
Institution is involved in this. We have some institution in your government
Кто,
responsible for this.
ну, то есть, допустим, в случае штатной ситуации, к кому обращаются?
Водитель сообщает диспетчеру службу
Нет, а у нас
безопасности.
безопасности к кому обращаются?
Радиационная безопасность. Радиационная безопасность.
Нет, а именно на правительстве, ну, на уровне контролирующих органов, или кому?
РБ наши. А они уже там начинают в корпорацию сам докладывать оперативному дежурному. Вернее, у нас оперативный наследие, они докладывают нашему оперативному, а тут уже оперативник, короче, из докладного процесса. Короче, наша служба безопасности получает информацию, докладывает нашему оперативному.
So the service, the security service department will receive this information. After that, they make a report to Rosatom Department of Transportation. Yes.
You ask for Rosatom before transportation.
Yes.
So I have
Rosatom is responsible and it to give you this license and others.
А кто выдает разрешение? То есть нам как Росатом выдает разрешение на транспортирование, на лицензию. Not Rosatom itself, but the federal state
Federal Transport Ministry. Federal Ministry of Transport.
Министерство транспорта.
Нет, Ростехнадзор.
So it's the regulator.
Скажите название государства. Надзор, технологический атом.
The state regulatory body on ecological, technical, and nuclear supervision.
Okay. And if Rosatom has several nuclear power plants outside Russia, for example, in Asia or Africa or Arabic countries. So all these safety regulations and transportation of radioactive waste, you follow that country rule or Rosatom rule?
Эти все требования распространяются также на ту страну, что перевозки отходов, или распространяются требования. Unfortunately, it is not in my yes. So here the demands of the Russian regulations.
Еще могут быть перевозки, но иногда на уровне разговора, когда высокоактивные перевозки. Да, активных, но разговаривать. Спасибо.
Another question. Sorry. What number will you use for transport of empty container made of depleted uranium?
Once again, please.
Вот. Цифровые коды. Ой, ну честно говоря, я не скажу, если допок, это два вот таких тома справочных. Не могу вам сейчас сказать. Тем более мы это не перевозим.
So the table which have these numbers, which refers to the packages, it is very big and big.
Это две книги допоков такие, там.
Container made.
То есть если контейнер сделан из измененного урана,
Вот, это уже это высокая активность.
Unfortunately, we do not deal. For just empty containers. А для пустых контейнеров какой номерной код используется?
Но опять же, это надо смотреть в этом. Если они загрязненные, контейнеры загрязненные.
It also depends if the container, if empty container is contaminated.
Нет? Ну тогда просто это груз, все. Зачем?
So in this case, there is no need of these marking.
Yes.
When the container is clean.
Мы совершенно...
Если он из объединенного урана.
Из объединенного урана. Допок, два тома допок.
In our daily activity, we do not use such type of packages with the uran.
Ну, не могу сказать, там две такие книжки, это справочник. То есть вас интересует код ООН, вот эти 4 цифры?
So what these 4 numbers are for the container made of
908, not 2908.
Ну, 2.9.
Это все берется из двух больших книг справочников.
So for this purpose, there are big table with these numbers, and in each number has its package. In our daily activity, we do not deal with such.
Потому что их помнить нереально, две вот такие книги, ну, это как справочник, там все это расписано.
Because there are a lot of these numbers, and it is unfortunately.
No, there are only 20 numbers for radioactive materials.
Там 20 всего для радиоактивных.
There is not so much.
Ну, тем более, мы с такими сталкиваемся, там тема разбираем. Спасибо.
Еще вопрос.
Да.
Код?
Да. Но это все книги всегда берутся из справочника.
Мы имеем дело в контейнерах, габарит, установка облучателя, защиты, из объединенного урана, принимаются отходы
Нет, именно какой код.
Какой код?
соответственно.
Ну, это все на справочнике берется.
Это ВП-53 есть, табличка.
Есть. И в доподе, кстати, все это есть. В доподе. Вот на консультанта сдавал. Все?
So,
Не ответишь?
if there is any questions, thank you very much.
Спасибо.
Uranium is still radioactive. This is dangerous. And all dangerous never mind. No, this is, there is another number for contaminated materials and others. Low activity things. Only people transport because there is a number 2908 is transport empty container. No, it's and there is another number 2909 transport from uranium to war
Yeah. I suppose I should this. No distance. No, I like with this one. Good resolution. Here, more light is going there. Light. Then more light. Yes. So resolution is missing. Light is just here, lot of light is there. You see that? Here. More light, yeah. Yeah, I can start here. Yes. Yeah. Can I give me a Okay, I am not look at me now. Yes. I am not doing it because and yeah. Yeah. Well, talking 15 years of practice. If you start there, I will make a start. Just come. Where is the thing? Where it is? You see the concept. With the hand off, please. Like this. Yes. Look at me. Your hand is towards the. Yeah, look at me. Yes. Look at me. Yes. Sequence. Thank you. Take it. Yeah. Yes, yes. I you know, please continue, sir. We are on time. Please continue. 50.
Да мы уже давно расписали. Okay, let me continue our lectures, and my lecture includes two things, predisposal operations and thermal technologies of radioactive waste treatment. Radon has begun to deliver and process radioactive waste about 60 years ago, and about 50 years ago, the first plant for incineration of combustible waste was created at the enterprise, since there was already a clear understanding that it was thermal processing that allows to reduce the volume of incoming radioactive waste as much as possible. Radioactive waste delivered to a specialized enterprise of the radon type are subjected to multi-stage operations. Sorry. Do you listen me well or not?
1 minute, sir.
One, two, three. Okay.
Yeah.
Radioactive waste delivered to a specialized enterprise of the radon type are subjected to multi-stage operations, the ultimate goal of which is to obtain the final product in a conditioned form suitable for temporary storage, as well as postponed or immediate transfer to disposal. And the great block of predisposal operation you can see here. They include operations which do not change physical and chemical properties of radioactive waste, and some operations of treatment radioactive waste, which change the physical, chemical properties of radioactive waste and its activity. The main principles of predisposal management of radioactive waste include reducing, if possible, the volume of radioactive waste placed for storage, conversion of radioactive waste to a chemically and physically stable state. Sorry.
So can we make it PowerPoint mode? PowerPoint mode.
Сейчас. Нет. Sorry. It's okay. Immobilization of radioactive materials in matrices and packages that prevent radionuclides from entering the environment. Providing radioactive waste acceptance to criteria for disposal before placing it for storage. In addition to this principle, the industry concept of the Russian corporation Rosatom includes into the system of predisposal management of radioactive waste the gathering or collection of solid radioactive waste at the first stage with classification by activity and material composition, combustible, non-combustible, compactable, metallic, and other groups, and the final isolation or disposal of radioactive waste. All radioactive waste entering the enterprise must pass the entrance control, which, if necessary, should not be limited to non-destructive spectral and radiation measurements. The characteristics of radioactive waste at receipt and during treatment in technological processes are recorded in the database and accompany all the movement of radioactive waste before its condition and after its condition. Gathering and primary sorting of radioactive waste in the places of its formation is the initial phase of the process of radioactive waste management, which largely determines the effectiveness of further actions at the stages of treatment, conditioning, and isolation of radioactive waste. The photos at the slide show the equipment for the primary sorting of radioactive waste at two nuclear power plants, Leningrad and Balakovo, and these systems are similar. If necessary, radioactive waste are sorted at a specialized enterprise in order to ensure the stable operation of technical equipment. Sorting radioactive waste permits to transfer it into a form that is optimal for, for further treatment, increases efficiency and safety, and reduces the cost of subsequent operations. In Radon, the work on sorting radioactive waste is carried out in a special box. The box is equipped with hydraulic and electric tools that provide opening of packages and items containing heterogeneous or non-morphologically separated materials, as well as cutting large-sized products into acceptable fragments. The choice of the processing method should take into account national standards for the form of waste for storage and disposal, the specific cost of storage, the cost of processing itself. During processing, the volume of waste may decrease or increase, depending on the type of waste and the concept of treatment. One should consider that during the processing, some waste could be decontaminated to levels that allow their limited or unlimited use. It is also possible to transfer to another industrial class of waste. These opportunities should be considered as ways to reduce volume of treated waste. The same equipment can be used at the stages of processing and pretreatment, depending on the characteristics of waste and the accepted scheme of managing solid radioactive waste. For example, crushing or pressing or compacting waste. According to the most common approach at the stage of pretreatment, radioactive waste is divided into streams: compactable, combustible, metal. Waste acceptance criteria for disposal, according to the regulatory requirements, contain many radiological, physical, and chemical parameters of radioactive waste and packages for it, as well as prohibitions or restrictions on the content of undesirable substances. The metal protective containers with the capacity of 3 cubic meters are used for the packaging of low-level radioactive waste. Intermediate active radioactive waste is placed into reinforced concrete containers with the capacity of 1.5 cubic meters. Containers are certified as Type A packages. Reinforced concrete and metal containers with radioactive waste are placed in the storage according to a previously developed procedure that allows monitoring and inspection of the package's condition before their removing for disposal. And this placement to the storage is the final stage of pre-disposal operations with the radioactive waste. The next stage is transfer to points of disposal radioactive waste. I finished the first part of my lecture, and we received some suggestions to discuss some method changes for management radioactive waste on some practical examples. Do you want it or not? Okay.
Unfortunately, the suggestion was made only today. Because of that, it's a little bit unforeseen thing, but we will try to do our best. So we will try to describe the following cycle of the radioactive waste movement. For example, we take the Kursk nuclear power plant. And at this site was accumulated 2,000 metal drums with radioactive waste. So our interaction begins from the message from the Kursk NVP that we have such a problem, and we want to transfer you all these large amount of waste.
обращении у нас существует определенные правила,
and the message back, we tell that we have the special procedure for waste transferring, and we suggest you to examine it and to make acquaintance with this procedure. According to this procedure, you prepare the document where you put the information which is demanded by this procedure. So the main thing which accompany the radioactive waste during the whole cycle, it is paper. So in this document, they describe the main characteristics of the waste they have. The main among them is radiological characteristics, the chemical content, and the type of the waste, and the type of the package in which waste are being, in which waste were stored. We try to receive information from them, what is inside each of the drum. The Kursk nuclear power plant answers, we do not remember what is inside each drum in particular. So in this case, we follow the procedure for this waste as for non-sorted waste. According to our experience, we can suggest that inside there are construction materials, solvents, some metal parts, and so on. So the first division who received this waste is the assortment workshop. And according to this slide, this stage, during this stage, there is hold to the input control and input control. And according to the input control results, and after this input control, those measure department make the conclusion if it is possible. Is it possible to
we can listen you. You are audible. Please continue.
So data received after use control, then those measurement departments make decisions. Is it possible to process waste by with manual waste, by manual waste? And as a result of this manual sorting, the waste stream is divided. The waste is divided into three streams. Intended for combustion, intended for pressing, or for conditioning, or right for conditioning. For example, if in this among these drums there is drum with which those measurement departments do not make a permission to work to make manual work, these drums can go for conditioning right for conditioning. Here we describe now the real work which we carried out several years ago. So all these three streams have its own life. The first goes for combustion, and for combustible waste can go for further combustion. It's also a work to mention the documents which are used for the different stages of the process of waste treatment. When we receive the request, we elaborate the document, which is the road map. Road map. This route map describes the whole process of these waste according to the information in this route map, the financial department determine the cost of the future work. Because in Russia there are several specialized organizations which can provide such services of already replaced treatment. So if all following the stages which I have already described will take place. The map for this process is not only used for financial department, but also used by the ecological department. Because it describes the following natural increased waste. And the order of this radioactive waste management, which is inside this map, is another procedure for the technological departments. In the frame of quality assurance, the technological department control all these following stages.
Контракты, которые мы заключаем с специалистами, договариваются дальнейшее.
The contract with the customer obviously includes the information of the further state of this waste.
Принципиальным условием будет либо мы переработаем и храним переработанные информацию в течение определенного времени.
The principal point is that the first way we can treat the waste and after that store in storage for them for the definite time period. In most cases, this time period is 5 years. The centralized sites for radioactive waste disposal in our country started their operation only several years ago.
Поэтому теперь контрактов в настоящее время становится условия передачи.
And now, the second objective point in the contract is not only the storage, but for example, the right transfer of the waste to the disposal site.
Тогда у нас начинается взаимодействие с национальным оператором, который отвечает за
And in this case, we started work with the national operator for disposal. We started work with this organization make Remediation, a specialized organization, not the producer of the waste.
Это взаимодействие начинается с того, что мы разрабатываем карту контроля процесса, контроль,
this interaction includes the assurance of the all ecological operations which were made with this waste. So after this whole operation, the final plan meets the set criteria for disposal.
В этой карте мы перечисляем все критерии.
This map includes all the criteria for disposal.
Указываем какими методами мы будем доказывать соответствие свойств отходов и
And we describe by which method we will prove that the waste characteristics after conditioning meets the requirements of the waste certificate.
также практика перечисляется другими
Also, this map includes documents in which these fact of meeting requirements is approved.
Эта процедура может
This procedure can take some time. In some cases, there is a need of additional consultations with again, national authority representatives.
никогда не был нашим
And then all the paperwork is done and all the requirements are met. The representatives of the national authority can come to our site and receive conditions for waste for further disposal.
Можно сказать, что в результате переработки
As a result of the work with the waste, at our site, a secondary waste is produced. For example, ash, the pressed material. These interlinked products, they also come to the process of the condition. This waste is put into containers which meet the acceptance, certified containers which meet the acceptance criteria.
Ну, обычно, если у нас
But in most cases, we deal not with such big producers of waste with 2,000 drums of waste. Also, for example, can be any organization which sometimes there are such cases that some organization, because of some decoration work or so on, find the object which is, for example, the authentic sources or radioactive source or some. Or, for example, it can be just some apparatus gadget with which interface has leading with the light making substance. For example, in Russia, there was such a case when the portrait of Stalin was made by planes with the use of So there are also such cases that some organization which is not waste producer can meet radioactive waste on the site. So in this case, even if the amount of waste is so little, all the procedure is almost the same. All the container procedure is almost the same.
Вместо глубокой перевозки и переработки
the exception of complicated process of assortment, this, for example, gadget or something goes for emission.
Если мы имеем дело с обработкой
If we deal with disused, deceived, radioactive source,
вы знаете, что
you know that there is great amount of them in different sections of industry and domestic use.
самых безопасных, малоопасных,
from the most common and more dangerous objects up to objects with high radioactivity.
Для хранения они размещаются раздельно в зависимости от склада, в зависимости от
For storage, they are placed in accordance with their characteristics. For example, the radioactive light, which is the source, and the type of radiation which it produces.
У нас на участке обращения источниками стоит около 20 контейнеров, заходим в различные
So we have about 20 containers, metal containers with different types of disused sources.
Наибольшие объемы представлены таким источником, как дымовые.
Greatest amount among them are small sectors which are commonly used. So we tried to describe the chain of the technological operations we make at our company. So we can speak about it by the end. So if you have any questions,
Do we continue? No?
Yes, please.
Yes. And so, let us proceed to the thermal technologies of radioactive waste treatment. Radon has developed and uses three main thermal technologies in its practice. For liquid radioactive waste, the most suitable methods are concentration with subsequent cementation or vitrification. Which provides one of the most reliable options for the immobilization of radionuclides in a chemically stable matrix. The conventional method of incineration of low activity radioactive waste is used only for combustible waste. For 50 years of technology development, Radon has worked out different combustion furnaces by design, and the technology of deep thermal treatment of radioactive waste of mixed morphology using plasma heating sources was also developed by Radom's experts. The method allows to obtain a product suitable for long-term safe storage in one stage. So, vitrification of liquid radioactive waste. Radom's experts have developed a technology and created the plants for treating liquid radioactive waste, high saline solutions, pulps, saline concentrates, by vitrifying a mixture based on liquid radioactive waste and glass-forming additives in induction melters of the cold crucible type to obtain chemically stable glass blocks. Here you can see the flow sheet of the facility of vitrification. The facility has 3 induction melters called crucible, which can work both separately from each other and simultaneously. Preliminary liquid radioactive waste is concentrated up to a saline concentration of 1000 grams per liter, after which glass-forming additives are introduced into the concentrate and the resulting past is loaded into the crucible in hot form. The cold crucible has an elliptical or circular structure in a cross-section made of water-cooled metal pipes with a rounded bottom. The crucible is surrounded by an inductor loop. You can see it here, which is moved up and down to warm up different zones of the glass melt. The past is loaded through the crucible cover. The glass melt is drained through a side drain device. You can see it here. Into metal containers. The temperature of the glass in the crucible varies from 1150 to 1250 degrees centigrade degrees. A garnish layer of the loaded mixture is formed on the inner walls of the crucible and prevents the contact of the glass melt with the metal body of the crucible. The cold crucible has some advantages. Non-contact heating, high energy concentration and productivity, wide operating temperature range up to 1800 degrees, and possibility of obtaining materials with a strictly defined composition. Among the numerous disadvantages of the cold crucible, it should be noted large energy losses, possibility of electric breakdown of the crucible, need to select the chemical composition and conditions for obtaining glass for each tank or batch of liquid radioactive waste. The method is very expensive for treating low-level radioactive waste, and we did it at our enterprise. It is not suitable for processing heterogeneous solid radioactive waste containing organic materials and metal inclusions. But the cycle of investigations carried out by order of Department of Energy of USA proved the high suitability of the method for treatment liquid high-level radioactive waste of a number of American storage facilities, Hanford, Los Alamos, and some others. An alternative method of vitrification of liquid radioactive waste is direct heating furnaces. Such furnaces, already the 5th generation, have been used since 1987 in the Mayak enterprise for the inclusion of liquid high-level radioactive waste containing components of spent nuclear fuel in aluminum phosphate glass. More than 30,000 cubic meters of high-level radioactive waste were treated in the vitrification furnaces of Mayak Enterprise. More than 7,000 tons of aluminum phosphate glass containing more than 750 million curie activity were obtained. Nevertheless, in countries with developed nuclear energy, the most acceptable option is considered to include radioactive components of liquid radioactive waste in borosilicate glass as the most versatile matrix with higher chemical durability compared to aluminum phosphate glass. Our enterprise, in cooperation with a number of institutes, is working on the option of replacing direct heating furnaces in Mayak Enterprise with more maintainable facilities with melters of the cold crucible type. The next type of thermal technologies is incineration. Incineration with a relatively simple technology makes it possible to most effectively reduce the volume of radioactive waste, which was determined the wide spread of the technology around the world. Currently, the facility is operating at the enterprise, which was put into operation in 1983. Over the years, it has undergone several repairs and equipment replacement. The facility allows processing both solid and liquid combustible radioactive waste. The basis of facility is a two-chamber furnace with grate. Packages of solid radioactive waste are loaded through the loading unit to the grates. Where they are burned down in the flame of the fuel burner. Sorry. After heating up the furnace, liquid combustible radioactive waste is fed through the nozzle into the combustion chamber. The technology requires careful pretreatment operations, separation and repacking of combustible and non-combustible components of radioactive waste before incineration. Oh, sorry. The technology of radioactive waste incineration operating in radon has following main disadvantages. Massive and low effective two-chamber furnace, high content of dioxins in flue gases, and I speak about dioxins some later. Formation of radioactive ash that requires additional conditioning operations. Low coefficient of reducing the volume of radioactive waste after conditioning. The high solubility and dusting ability of ash require adequate measures for conditioning the incineration product. Ash from the furnace hopper is discharged into metal drums with a capacity of 100 liters. Which are sealed with a lid and in return placed into a metal drum with a capacity of 200 liters. Here you can see illustration. The inner drum is the drum with ash residue, and the outer drum is 200 liters drum. The free internal space of the 200 liters drum is filled with cement grout, and the drum is closed with a lid. Then 2 liters drums, which with ash are placed in a protective metal container. Metal container. One can place 5 drums into metal containers and only 4 drums into concrete containers. Metal container is filled with sand or filled with cement grout for concrete container, depending on the hazard class of readiness. This method leads to a reduction of the initial volume by only 4 times. Radon's experts have developed a new single chamber grade furnace, like here, for radioactive waste incineration and modernized gas purifying system. One new incineration plant is operating at the Kola nuclear power plant. The assembly of another plant is in the ДХК, горно-химический комбинат near Красноярск, has been completed. Here you can see the layout of the radioactive waste incineration plant. And the next thermal technology, plasma technology. The plasma pyrolytic technology of deep thermal treating radioactive waste developed at Radon and implemented in Pluton plant is an effective alternative to the incineration method. In 1907, a pilot industrial plant Pluton for radioactive waste plasma treatment was put into operation at Radon. The basis of technology is the shaft furnace, which is consists from 2 main parts, the shaft and the hearth or melter. The shaft provides high temperature gradient, which allows to dry waste at the upper part, to provide a pyrolysis process in the conditions of oxygen lack at the middle part, and oxidation of carbon residue in the lower part. And then heating with plasma torches provides ability to melt the inorganic residue, so-called slag, and overheat it to make it homogeneous and to pour it into metal receiving containers. And the difference of the technology from other plasma technology is in construction of furnace. The furnace of shaft type. You can see if you have the temperature in the melter about 1,500 degrees, the temperature of pyrolytic gases at the upper part of furnace is about 200 degrees. So this construction suppress the exit of some radionuclides. First of all, cesium 137 and 134, and some heavy metals like lead, cadmium, and some others. The metal is condensed, and the cesium are condensed in the middle part of furnace.
So there is no filter.
Sorry?
There is no filter on the outlet to control these or minimize these emissions of cesium or cadmium at the outlet.
I misunderstand you. Sorry.
So the outgoing emissions in the chimney, in the pyrogas outlet,
Yes.
there is no filter to control or to stop the cesium or such kind of elements to expose to the air.
If I understand you correctly, you want to know, do we control the emissions of radioactive radionuclides at the outlet of furnace? Yes, we have carried out some experiments, some balance experiments, where we found that emission of cesium isotopes doesn't exceed 10%, and emission of cobalt-60 isotope is not is less than 2.5%, and the emission of alpha of heavy alpha isotopes of uranium, first of all, is less than 1%. We control the exhaust of technological gases or of gases into the atmosphere by technological measures. Among them, sampling of aerosols from the gas stream, and we have not any problem with emissions of radioactive waste because we have the very heavy and heavy system of gas purifying. I will show it some later. Okay. Okay. Oh, sure. Plasma technology allows treatment of solid radioactive waste of complex morphological composition containing both combustible and non-combustible up to 40 to 50% components. The product of radioactive waste plasma treatment is a slag compound with high mechanical and chemical durability. Plasma technology is applicable for solid red waste accumulated earlier in storage facilities and formed during the operation and decommissioning of nuclear power plants and nuclear facilities. The nominal capacity of Pluton plant is about 200 kilogram per hour. The operating temperature in the shaft furnace melter varies from 3000 to 1300 to 1400 degrees. And sorry. dependent on the viscosity of the slag melt and is provided by two plasma torches. By two plasma torches with a capacity about 100 kilowatt each. According to the terms of the license, red waste of very low and low activity levels packed in craft bags weighing no more than 15 kilogram each are received for treatment at the Pluton plant. Unlike the most common grade incineration facilities, the shaft furnace of the Pluton plant treats bulk and powder materials, ion exchange resins, silts and slurries, thermoplastic polymers, waste with high humidity. The throughput of the plasma plant depends on the morphology, ash content, humidity, and the number of other solid radioactive waste indicators. Restrictions are imposed on the content of refractory components, metal and materials containing aggressive components, chlorine, sulfur, phosphorus, and nitrogen compounds in the treated waste, which create additional corrosion loading on the gas purification system and the cost of ensuring the efficiency of capturing harmful chemicals. This table compares two possibilities of two technologies, incineration and plasma treatment. I want to say that plasma treatment is not universal technology, but it widens possibilities very highly. The scheme technological flow sheet of the Pluton plant includes a shaft furnace with units for loading radioactive waste and removing the product slag melt, pyrolytic gas afterburner, and multi-stage gas purification system. The Pluton plant was patented not only in Russia but also in a number of foreign countries. Direct current electric arc plasma torches developed at Radon are used as heating sources for the melting of the shaft furnace and the pyrogas afterburner. Plasma torches are 2.5 times more efficient than the fuel burners in terms of heat transfer and contribute 3 to 4 times smaller volumes to the flue gases of the plant compared to fuel combustion devices. You can see it here. The plasma torches provide heating, melting, and homogenization of the slag melt, which is drained into metal receiving containers and cooled in them. Two plasma torches are installed in the melter of the shaft furnace, one of which can be switched off in the stationary mode of the furnace operation. The refractory materials used in the melter determine the service life of its operation and the duration of the inter-repair period of the shaft furnace. So we carry out laboratory tests of refractory samples from various manufacturers in advance in order to obtain reliable information about the thermal, erosion, and corrosion durability of the materials offered. You can see here the results of laboratory experiments. Receiving containers with cooled slag are placed in protective containers of the KMZ of MZK type depending on the radioactive waste hazard class. The plasma technology of radioactive waste treatment provides maximum volume reduction coefficient. For certain types of radioactive waste, for example, pressed in drums, the volume can be reduced by 10 times. The shaft furnace works optimally in the range of the content of non-combustible materials in solid radioactive waste, concrete, cement, soil, thermal insulation, etc., from 10 to 40%. If the content of non-combustible components is beyond the specified limits, the shaft furnace converts into an incineration furnace, or the waste reduction coefficient falls below 5. You can see it at the diagram from 40%. The pyrolysis gas formed in the shaft furnace contains organic and inorganic combustible components that provide the calorific value of pyrogas at the level of half the calorific value of waste coming for processing. This property determines the possibility of operating the afterburning chamber in the autothermic mode without additional heating sources. Okay. Oh. Strange color. The volume of flue gases of the Pluton plant in specific indicators is about 2 times lower than the volume of emissions of radioactive waste incineration plant. According to results of surveys, it is shown that the content of highly toxic substances in the technological exhaust of the Pluton plant into the atmosphere does not exceed European standards. First of all, it relates to polychlorinated dibenzoparadioxins and its homologs. The nature of the plasma pyrolytic process is such that it reduces the formation of the most dangerous toxicants, polychlorinated dibenzoparadioxins, by about 4 times compared to the waste incineration process. An interesting detail on the current topic of decarbonization of industry, the world problem. The plasma process reduces the emission of carbon dioxide 4 times for each kilogram of treated waste compared to the process of incineration of radioactive waste. They are in trends.
I have only one question.
Mm-hmm.
Can I interrupt? Can I interrupt right now?
Yes.
No. My question is, in the plasma torch,
Yeah.
what is the source of plasma torch? That is not in the construction facility. In the picture, what we saw before, the plasma torch which goes more than 1200 degrees centigrade. So, what is the source? The nuclear fusion reactor is there. You have a source. What is the source of?
Да, может быть, нужна будет помощь еще. Да, я. Что является?
So there is a fusion reactor should be there. So in that construction picture, no, before, yes. So we have a plasma torch, right?
Yes.
Which goes more than 1000 degrees centigrade roughly. So where is the source of that plasma torch? In the
Является источником для плазматрона, да?
so you have a fusion reactor.
Plasma torch is a device working at the
I understand,
direct.
but the source, where is that in the picture? Where is the source of that? How you produce that much?
Ну вот, пожалуй, это здесь. We use compressed air as a working gas in plasma torches. We have no any fuel, no any gaseous hydrocarbons in plasma torch. We convert the heat of electrical arc inside the plasma torch
But the electric arc can't,
cathode and anode.
yes, yes, I'm understood.
And
The electric arc can't produce thousands of degrees centigrade. What? Yes, but
we obtain
it can go to 12,000 also in ITF, for example. But what is the source of electric arc?
Plasma is a susceptible matter. It doesn't mean that it requires fission.
Electric arc, what is the source again of electric arc? You need that much. You need that much amount of kilowatt voltage, right?
Yes.
Where is there? That's my 100 kilowatt. Is 100 kilowatt. It's
Yes,
not enough to produce thousands of degree temperature arc.
we have very high temperature electrical arc, which energy takes compressed airflow and transport it outside the plasma torch. This.
So my question is very simple, sir. 100 kilowatt is the input, right? Electric energy. How it produces more than thousands of degree centigrade electric arc, plasma arc.
At the temperature of gas flow at the outlet of plasma torch is about 3,000 or 4,000 degrees.
Yes, that's possible. That's not understandable. But
And
your
what is
input is
problem
100
with
kilowatt. You need more.
Yeah.
You need more kilowatt for that.
Why not? Why not? We have really.
Okay. Okay. Then
This is the thermodynamic temperature.
the confusion is, you see, the main feature, the type of current is not alternating current. It's a DC current.
DC current, yes.
So DC current, 100 kilowatt input, producing 1000 degrees centigrade as an electric arc. That was my question. What is this? How it is possible? It's not alternating current. It's a DC current.
Yes, it's DC current. DC current.
Are you familiar with welding?
Yes. Welding is 200, 300 degrees
I'm not
centigrade.
saying that. I'm just saying. So it's a DC current.
Yeah, but 200.
To create an arc,
Yes. 200, 300 degrees centigrade for welding, and we are talking about
you will realize that this is
1,200.
an arc. I'll maybe talk with you.
Okay, okay, sir, it's feasible. If my colleague is saying it's feasible that welding is what we are doing in daily life is 200, 300 degrees centigrade. And that's also DC. But
Well done. And
I'm not comparing the two. I'm not comparing the two. I just said DC current.
yes, but DC
well done.
current.
And plasma cutting.
Maybe I will check myself. Maybe I will educate myself little bit. It's possible.
Possible. Okay.
With this specification, can we get these slides? We can get these slides. I can get from you. Okay. Okay. So because with this specification, maybe I will educate a little bit myself.
То есть мы дальше обсуждаем. Okay.
Please.
I continue.
Sorry. Yeah. Sorry. Because with, if this is possible, we can take a such kind of engine to space. if we can provide more than thousands of degrees centigrade with 100 kilowatt DC, we can take it to the Mars or Moon in the space. It's feasible. And that's a big challenge for us. Normal RPG also doesn't have this specification. Radiothermonuclear transmitter, RPG. So, but okay, I will discuss it. Yes.
Нет, сами отходы горючие, это сначала идут затраты энергии. Надо сейчас, это не надо. Ну, совсем о другом, речь идет. The evidence seems impossible. Seems to be impossible.
Maybe I'm not. I have to educate myself a little bit.
Okay. The slag obtained by the plasma method contains more refractory components and less alkali metals compared to borosilicate glass. So slag melt viscosity is significantly higher than the glass melt viscosity, and a higher temperature is required to drain the slag melt. You can see it in this diagram. Thus, the plasma technology has a number of significant advantages over traditional radioactive waste incineration process. Due to the reduction of radioactive waste volume by 10 times, the plasma method reduces the need for certified containers and saves the volume of radioactive waste storages, eliminates a number of waste conditioning operations. Taking into account the subsequent transfer of radioactive waste for disposal, plasma processing reduces the cost of managing radioactive waste by 50 to 25% compared to traditional methods of incineration combined with compaction of waste. Is there a problem with plasma technology? Yes, we have problems. First of all, this is the quality of refractory materials that ensure the service life of the shaft furnace melter. And the second problem is the quality of training and responsibility of the plant operation personnel. And significant way to reduce the cost of managing radioactive waste during the operation and decommissioning of nuclear power plants could be its sorting by morphology and classification by radiation indicators in the places of its formation. Very strange picture of potential use of pyrolytic gases. A number of theoretical scientists suggest using the heat of pyrolysis gas combustion to generate electricity and transfer the process of radioactive waste treatment to self-sufficiency with energy. The idea is tempting but unrealistic. Its implementation requires a high caloric content and stable composition of waste, a system for cleaning pyrogas from aerosol, soot, and tar. Do not forget that we are talking about radioactive waste. This could not be done even for the municipal waste treatment complex in Israel, a dry place. For the production of electricity using gas or steam turbines, deep purification, high caloric content, and stability of the composition of pyrogas are required. This question isn't relevant for nuclear power plants. Therefore, the most realistic heat recovery product of the process is hot water. Now, When the nuclear industry has started the real decommissioning of the stopped power units and nuclear facilities, the question arises how to use better thermal technologies for treating the generated radioactive waste. There are two options here. A regional center for management of radioactive waste similar to radon and regional and local centers for radioactive management, an example of which is the Experimental Demonstration Engineering Center for Decommissioning in Novоворонеж. Since 2017, Demonstration Engineering Center has been operating a complex for radioactive waste plasma treatment, the prototype of which was the Pluton plant. The complex has technical characteristics similar to the Pluton plant, and the annual capacity of the complex is 1,500 cubic meters of solid radioactive waste formed during the decommissioning of units 1 and 2 of Novоворонеж NPP. The center also has facilities for managing other types of waste and radioactive waste pretreatment operations. The plasma treatment complex has a modern powerful gas purification system and an automated process control system. My report has presented three types of high temperature technologies for radioactive waste treatment. The technology of liquid radioactive waste vitrification in the inductor melting device called crucible is currently actively developing in the USA, France, and China. The incineration process remains the most common technology of thermal conversion of radioactive waste. Plasma technology allows for reliable and economical disposal of radioactive waste now without postponing the solution of the problems for decades. Thank you for your attention. Any questions? Oh.
Thank you.
Thank you very much.
Thank you.
The break.
Все подпитать. Вот эти вот огнеупоры, которые мы использовали с рисуночками, какого состава? И вообще вот эта вот печка, это разработка россиян? Да? Это полностью ваша. Радон или специально какая-то фирма? Или это ваш радон?
Первый патент был получен на Альянс-Гамма, российская организация, но сейчас, к сожалению,
Can I have the slides, please? I'll write the email and get the slides. Can I get the slides?
Получить слайд просто.
Ну, презентацию нашу точно.
I'll say, I write, madam. I'll write to.
Вы оставляете, да, слайды здесь?
Yes.
He's delivering all slides.
Okay.
As always.
You can come here.
Thank
you.
Is interesting for you?
It was after all the lessons, how many lessons we have attended, this is maybe one of the best. Because of the information, the plasma technology used for nuclear waste management, one of the key and modern and very updated information.
I'm sorry for my English.
But it's really good.
Значит, это ваша своя разработка, да? А какие огнепоры там используются? Вот вы рисунки показывали же? Какие цифры просто я не знаю.
Израильтянами разрабатывали.
У них тоже такая используется, да, сейчас плазменная
У
технология?
них
Они тоже делают?
плазменная установка была, демонстрационная плазменная установка, тоже в 2007 году они ее пустили в эксплуатацию, и мы помогали им ее пустить. Но это установка для муниципальных отходов. Производительностью 500 кг в час, она именно как демонстрационная используется. Вот, и, наверное, грех на нашей душе есть за то, что мы не сказали состав огнеупора. Вот поэтому я вам всю информацию не выдал.
Не, мне просто
Но,
интересно,
здесь...
какой класс огнеупор, я огнеупором
Да.
занимаюсь. И я в Узбекистане работаю, мы только будем начинать это в атомную энергетику входить.
Понятно.
В каком направлении нам двигаться?
Вы знаете, проблема в том, что у нас нет стабильных поставщиков огнеупора. Кто-то поставил сегодня хорошие огнеупоры, завтра они либо отказались от этого, как, например, одно из предприятий здесь, в Подмосковье. Они сказали, нам гораздо интереснее делать пары трения для насосов, чем вам огнеупоры, потому что мороки с нашими огнеупорами много, мы требуем достаточно четкие размеры. Вот. Из тех огнеупоров, которые мы использовали, это оксидные огнеупоры на основе корунда, и с добавлением оксида хрома, оксида циркония, разных сочетаний. Да. Ну вот они прессованы. Более мелкие порошки. Вот. Какой-то из этих образцов был выполнен из жаропрочного бетона, и потом после выдержки и обжаривания сформированы балочки. Были электроплавленные типа бодолита, корунда, бакон, известного тоже материала. Были различные модификации карбида кремния, использованы. Да. Ну, тоже вот с разными результатами.
Это вот они в таком виде, да? Это они?
Ну, эксперименты мы проводим, да.
Вот это вот?
Нет,
это не связано.
Нет, здесь просто написано, что вот это 4 цикла выдержали, вот здесь вот 8 циклов выдержали, эти 5 циклов выдержали. Суть в том, что мы проводим эксперименты в высокотемпературной лабораторной печи, при температуре примерно 1400-1450, помещая в тебе имитатор шлака, в него окунаем огнеупоры, и одновременно получается, есть зона раздела фаз, есть,
вот это не дотрагивалось до шлака, значит,
до шлака не дотрагивалось, но иногда то, что делает горячий газ, горячий воздух,
еще хуже,
да. Вот здесь вот, видите, эти зоны вспухали, ну и вот разные совершенно по качеству огнеупора получались.
То есть у вас это все еще самый горячий вопрос? Огнеупор.
Он может быть не горячий, мы примерно знаем, чего мы хотим, но мы не можем найти производителя, который это хочет сделать.
Ну, у нас вообще производит только шлак, шамотные огнеупоры, кислотоупоры производят. Корундовые пытаемся делать, но остального у нас нету сырья, к сожалению. Магнезиты мы очень хотели, хромагнезиты хотели.
Мы работали с МДЦ «Вопросы». Если вам известно, это фирма.
Мы пытались в прошлое провести про то, чтобы они нас провели по заводам, что-то у них связи не очень хорошие. То есть заводы мы давно не видели, ваши российские.
Я говорю, что с этими заводами не пойму, что.
Они не попадают.
То они попадают в другие руки, то из чисто экономических соображений, то просто выходит из строя постепенно вакуумное оборудование, скажем, вакуумные печи, в которых получали нормальные огнеупоры. Потому что вот по всем этим огнеупорам у меня есть одна, как вам сказать, уверенность, что здесь нарушается процесс их приготовления, их выдержка, отжиг. То есть это температура, это вакуум, это время, которое мы видим, как у нас разрушаются огнеупоры. И если наружный слой шлак, скажем, уже зацепил частично растворил, то внутрь находит уже очень быстро. То, что в середине, плохо выдержано. Ну и вот заставить сделать то, что нам надо, очень тяжело.
У вас вот это вот шахтная печь же? Шахта
Да,
это шахтная,
это
да?
шахтная печь, да.
Шахтная печь, она у вас по бокам обработана огнепроводом, да, смысл?
Нет, она вообще сложная из огнепровода. И имеет только металлический корпус.
А, только корпус и изнутри разные виды огнепровода. Да, на самом начале назвали.
А, я уже пролистал.
Да.
Вот она,
Да.
Ну, здесь показано, конечно, вот
сверху металличка, да?
специально показаны 3 типа разных огнепоров.
Желтый, коричневый,
Да,
темно-коричневый.
коричневый, желтый и совсем желтый. То есть это внутри шамоты класса ША. Дальше это легковесы класса ША-1 и снаружи легковес 0,4. Здесь ничего такого нет, необычного. Самое главное, получается, вот из чего сделан сам правитель. Вот эта вот часть. Потому что здесь материал должен быть стойким к расплаву шлака, агрессивное воздействие очень сильное и выедает даже вот так вот.
То есть
вот здесь
вот это
за счет,
место, да, вам самое важное?
Эрозия за счет газовых струй нейтронов. Ну, здесь можно там много разговаривать.
Да. Очень интересно, спасибо даже. Я просто не стала всю компанию нашу задерживать, как товарищ.
Вот. Ну, установки сжигания. Да, говорю, на Курской атомной станции пускал установку сжигания.
Ну, наверное, вы к нам еще придете, как мы определимся с местом.
Думаете, да?
Электростанции, да.
А, ну да. Так а все-таки двигается в этом направлении, да?
Да, будет Росатом у нас ищет место. Это что за длительный процесс, оказывается? 2 года уже ищут?
Я думаю, что 2 года уже отмахивается Росатома.
Нет,
Да.
Планицы лета пустите. Speaker was no air there.
I think so.
You should put планицы лета.
No one wants to. Ask They would like to drink tea or coffee. So they would like to drink tea or coffee either. I would like to get an old presentation up to now.
Okay, I think we will leave the available, or I can
Can you
copy.
Yeah. Can you help me?
Yes.
There must be. I can take another one because it's going accumulated more and more, and then it's going to very long time to be copied.
Universal, yes. Once connected to words.
It's not connected.
No, I can't connect to
Can you open here? Yes,
Yes.
this one. This one. Okay. And can you open new new file?
to make me.
Yeah, yeah. New file. Okay. Oh, how can I write? Okay. It's okay.
One is PDF, the one is
Yes. And another one.
this line, so July. Oh, sorry, today's.
Not only today. Up to all of I would like to get copy up to now. Yes, 5, 6, 7. Yeah, all of them. You can take it.
And then just it's just copy.
Mhm. Mm. Ah, Turkey. Turkey came from Turkey.
Nice country. I've been twice.
Really? Antalya?
In
Istanbul?
Istanbul.
Yeah. I came from Sinop, which is in the Black Sea. It's a really nice place, I think, but we haven't got a long time sometimes.
Not
The
so
summertime is very short than Antalya. Yeah, it's.
So I think everything is done. I'm just trying to present it. I just don't know today maybe because of this photo. I can't connect two words between each other. It's terrible. Never.
Your name? Ella. Okay, Ella. Nice to meet you. I am Manny. Mariam. It's, I think it's easy name.
Yes, we also have
Yeah.
our company, Mariam.
Very, all of the world, I think, has this name. Because, you know, it's belongs to, how can I say, Hilary. Mariam, mother made of Mariam like that, you know? It's the same name, therefore many people has this name. Thank you very much.
You're welcome. And what is the organization? It is also connected with radioactive waste management.
Yes, my field is radiochemistry. Also, I am interested with leaching process. Many different bioleaching, acid leaching, and basic leaching, you know, alkali leaching. I'm interested also detection system, which we are using very low level activity. That detection system also I'm interested. And we are trying to develop new detection systems, new detections, not detector, but yeah, processors and design of detector. And because of I am also interested in ionization, radiation meteorology. You know, that we field try to prepare reference material. That's why the direction system is very important, especially if we can have to use primary standardization methods. And pasta management is the very interesting for me because of I am giving a lecture to my students, and then I also interested with this field.
We also have a quite big ecological department, ecological and laboratory detection of very low level rare elements and several also. Make some evaluations and develop the precision detection, make a reference because
Yes,
very important work.
I think so. Especially I use alphas, alpha emitting, alpha particle systems. I use this system. If you are working in the alpha measurement radiochemistry, you have to use. Otherwise, you can't do anything else. It's very interesting. But last time management also very important. Actually, we haven't got so much radioactive waste on collecting from medicine because we have nuclear power plant and this
Being under construction.
Yeah, actually, also from building this.
For Akku, we participate in the conflict of operation radiological monitoring.
Yes, but later I am sure we need to distinguish so much because we have to prepare everything for high level last time radioactive last time.
But for the designing project, the amount of waste is already limited by the design. So it is easy to predict what the amount will be. And here, the main problem was that before 2011, different organizations supervised by them collected a large amounts of waste, which were not all knew about them. So, after in 2014, there was made with a state register, this ways of high level and so on. Also, they determined compare for the fate of the opportunity, and in order to the new producing waste, also we have plans for waste producing. And it is very important, and it can be now predictable.
I curious about Kayuka, red processing.
The processing
in Russia?
Yes, because we have the whole cycle of food. And all the processing is made at Mayak, which occurs in Azorsk. It is not far from Petersburg. There is the processing plant, which and then process it to the fuel of BM reactors. If the fuel was produced in Russia and it was sent afterwards to the country, we receive back fuel and make it the processing.
I think also we will receive our food spent for this receive that.
Yes, because
from
if we have produced it, we take it back as well as the radioactive source. If it was produced in Russia, it can be sent back, but some countries, like Cuba, for example, they want to send a lot of resources from the time of the Soviet. So these are already the legacy waste and they're not moving Russian countries. Now the project with Cuba the complex for removing resources into certified container for long-term storage. So this is not the direct area of my work. My area is
interesting storage. I mean, interesting storage.
Yes, but it was always interesting for me, and my colleague, who is a technologist, like maybe people try to present it,
Sergey.
Yes.
Sergey.
But I have been working with radon since 2010. First, I worked at the storage site itself. And on the stage of waste final product properties analyzing. So also emission methods, like the Senate matrix, like the polymer matrix. And because of that, of course, I was in every place we follow.
I should say you are translating very nicely.
No.
Yes, we can understand.
What has happened?
I believe because they actually couldn't understand anything else the Russian, you know?
I want to remove the slide because my phone has already in his presentation. You used it.
Meryem hocam sunum.
Yeah.
Stage is yours.
I will do it.
Hadi hocam.
Я полагаю, что
Göçende yazdık bu gelmez. Sırlarca taştı.
теперь, видимо, она что-то следила. Она бывает такое, что... Теперь потом...
Çarşamba günü akşam uçuşu 255 kişi yapmışlar. Çarşamba günü uçağı büyük uçuşlar. Gayet yer var. Perşembe günü 355 yaparlarsa Perşembe senin uçağın akşam senin uçağın gayet rahat. Onu söyleyeyim zaten. Ben iki yoldan kesinlikle. Şey sordu en azından hangi havalarından onu söyler misin böyle? Onu söyleyeyim.
Dear friends, if you please may I start?
Yeah. Yes. The microphone is not working.
It is not working. I think the calculator is over. But I'll try that.
Pardon, I'm waiting. Öyle mi? Okay.
I will try to speak louder.
Yeah. Maybe we can close down.
Я вроде как места так заняты. Уже, наверное, поменьше людей осталось.
Да, там сейчас два на встречу. Ну, подойдут.
Да, хорошо. Да, что у него батарейки.
Да, это сейчас.
Aslında şey kayıt grubu artık oldu.
So now I think it will be easier to hear me.
Okay. Yeah.
I'd like to say a few words about the storage of radioactive waste. And it seems reasonable to start with the definition of the terminology. Here is the exceptions from EU safety glossary. First of all, storage, it is the process of holding of radioactive waste sources, material, spent fuel, and so on, with the intention of its retrieval. And by definition, it is the interim measure, and all the process of waste management must be ended by, of course, disposal. But the main contrast to storage, that the waste after storage, during storage, they must be retrievable, and their fate can be not still defined completely. So, because of that, it is an interim measure. So, also, these technology, according to this glossary, make the disclaimer that the object can be intended for the uncertain purpose, first of storage, and after that for disposal. And the decision of the fate of these storage days is in most cases is defined by the time of the expiration period, expiration of its operation. So in this case, there can be two ways. The first one is its closure, and the storage can be with the help of several measures maybe defined as disposal, or the prolongation of the status of the storage, or the status of this construction as the storage facility. So this is the main, these two definitions, disposal and storage, they contrast, but in most cases, the procedure of storage is includes almost all the elements of procedures and processing and other procedure methods similar to the disposal. We can here can divide storage, the term of storage, for several processes. So the first one is temporary cumulative storage, and we in most cases use it for waste reducers. So the time of the time during which the waste are kept on the territory of the producer, it is this temporary cumulative storage. And for these, according to the requirements of the legislative, there are some requirements, the main for which are, first of all, it is the plan of working organization. So every legal entity who produce waste must have the project of the system for handling of this waste in the place of their formation, and must be organized the procedures of temporary storage according to the properties. So first of all, according to the properties of waste. So radioactive waste must be stored separately from other technological or industrial waste. They should be separated by categories, by specific activities. My colleague already mentioned this classification. Also, according to the state of matter, solid and liquid, physical and chemical properties, and also according to further processing of method of their processing. For organization of this work, each waste provider must have special premise which is equipped in accordance with works connected with open radioactive sources, which is radioactive waste is, and the time of also of this accumulative storage, it is also defined for not to exceed it. Also for the next category of temporary storage is for radioactive waste which contain radionuclides with short-lived radionuclides with the decay period of less than 15 days. In this case, these waste just are subjected for storage on the place of their formation before the end of the decay and the minimization of the level of activity from it lower when the requirements of legislation are. Also here there are some definitions from the EAA document, which is storage of radioactive waste, and here we presented separate provisions which we thought to be the most important. So, as at the first slide of the presentation, we said that the main difference is the intention of retrieval. So, this intention of retrieval must have the estimated and defined period of time. So, in Russia, for storage facilities, in most cases, this time of operation for its design was 50 years and less. Why it was so? Because during such a period of time, it is possible to formate and make this decision because it is the term of two generations when the information is when information can be accurately passed through the people who operated, and the further fate can be relied on the knowledge which was received during this not very long time. But according to safety standards series, also there is the limitation for this storage can be also more, and of course up to, for example, it may be 100 years, but it also when the period time is very long, the postponing of the final decision is in this case can be a very complicated thing. For long-term storage, the main technical considerations for assurance of safety storage are by this point of this. It is, of course, engineering systems, facilities, and control of all the process of storage. And also it is the management of information. Information must be carried out with great accuracy in order not to lose some important things and about the waste content, about the data, and so on. So the management of records here is also a very important point is mentioned, and also it is the control of the intrusion into the storage facility, because of course it is the object of it is of course an object, non-permitted intrusion must be excluded. Also, then the more short periods of life for storage is required. The stages of its control can be, for example, can be held in after several years of exploitation, which is also, and after that they need prolongation of the possibility of further work, and it is very well because these procedures they make it possible to receive additional information about the physical state of the waste inside, the physical, and to examine the possibility of radionuclide diffusion from the waste from the storage facility, and so on. So if this information is received, it is it also gives the possibility for further designing and construction of the new objects. And if we here also once again mention disposal, all these main requirements which are defined in the safety requirements of the EAA, they are all suitable for the storage. So first of all, it's understanding of the disposal facility and confidence and safety. Also the containment of radioactive waste. So during organization of storage facility, it is also a very important question. The aim of storage and facility both, of storage and disposal both, it is isolation of radioactive waste from the environment, so from the inhabitants, and also here existing disposal facilities. In any case, it is possible then objects of different generations. For example, I will show it in an example of our company. They can be in present. So the storage facility which was designed in the 60s, and the new one which was designed 10 years ago, they both can exist with the suitable organization of procedures of fair management. The main the thing is also which is suitable for both these processes, the storage and the disposal, is first of all it is the accurate and right choice of the site placement, because this thing can help to not to have problems with some requirements in future. So let's go to the next slide. The process of storage as well as disposal, it starts from classification, because all the further procedure actions with waste, they have interconnectedness between each other, which is also defined by all EAA principles. So if all for each level level for waste, the procedures is not similar. It is for each. It is it differs, and it is important that the management of waste must start from the moment of fair producing of this waste, and determining the class, the category to which it is so so the class determine the further procedures for it from the very beginning. When waste is a long-term waste is carried out for a long period of time, for example, 100 years, it is not even for a very long periods, but there needs to be long a term assessment of the safety of the engineering barriers, and of course, according to classification, initial classification of waste, it is easier to understand the way of assessment, of long-term assessment, which must be made for the containment of the waste itself. As my colleague has already started on all these operations, but I would like to here I'd like to determine the definition of the interim storage. So this interim storage, it is storage of waste from the moment of fair formation up to the moment of fair conditioning. So when it defines the time when we receive the ready package for further disposal. And here in our country, this time, this period is determined, and it can be prolonged or postponed in order for not to create the amount of waste at each waste produced. So in general, according to the law, the waste producer is responsible for this interim storage, during which all these operations must be made. Of course, not all the waste producers, they have special equipment and staff and premises for this work. And in this case, they transfer these waste to the special organizations to which, for example, our company Radon is among these specialized organizations. And we not only make all these procedures here, but also provide the long-term storage of the ready packages, which meets the acceptance criteria for further disposal. So this here we determine as long-term storage. As I have already said, not all organizations who are waste producers, they can process the waste. So we receive waste for processing from many organizations. The main are in this list, so among them institutional waste, factory researchers, medical waste, industrial enterprises are also providers of waste, and nuclear power plants, and so on. So every year we receive from 3 to 400,000 cubic meters of waste, and deal with more than 100 organizations. We receive and process the waste only of two types according to Russian classification. It is almost the same as ENA classification with additional 2 points. But we deal with intermediate level waste, spent sources of category from 3 to 5, very low level waste, and very low and intermediate level waste, and spent sources. So this is the status of it. We long-term storage facility for radioactive waste, and we provide this activity since 1960. And here you can see the plan of our company, of our site, storage site. And it is quite interesting for research, because at one place we have 3 types of storage facilities. So these rectangular gray areas, they are the most ancient storage facilities, which were in operation in the period of 1960-1970s. Here you can see the next generation up to 2000 and here is the modern one, surface facility for long-term storage with the intention of retrieval and also with possible further status of the disposal facility, which is now used for long-term storage of radioactive waste of the third and fourth category. Now I will say a few words about the construction of all the types of facilities we have. Here is, as I already said, the most ancient one. So the loading of waste, the principle of its organization was the prepared construction. Near surface one, which was so just I have forgotten to say a few words about the very important thing which I have mentioned. It is the selection of the site place. Here we have our storage site is situated on quite high level of the surface. It is higher than almost all the objects which are near. And also the hydrogeological characteristics of the storage facility is also was chosen as a natural barrier for preventing of radionuclide transfusion. And these first storage facilities, first they have the status of of disposal sites. So in the 1960s, it was enough of this construction to be as a disposal facility, and the waste in different packages was loaded inside the near surface construction, which was made of the basis of which was made of concrete slabs with walls and dividing walls. And the places will put it in its initial package inside, and layer by layer, it was poured with cement grout. Was it was the very the design of this storage facility was made long ago, but even now, if you think that it does, but even now when it doesn't meet all the criteria, all the requirements of the safety storage, we can mention that here are listed almost all the barriers which are used here for prevention of radionuclides spreading. And this one, the old one, has the only one problem at the waste will not was not put into containers. These old storage facilities, they are the objects for and I say it why, because rules and regulations stay the right time, with time, and if we now find it not suitable, who says that in 20 years, the storage and disposal facility we are designed now will meet the all requirements of the future. So because of that, nevertheless, the periodical examination of these storage facilities is made, and especially when we prolong the certification and permission for exploitation of this site, and its condition shows that the condition of the waste inside and the construction itself is quite durable and still in most cases make it function. So here can be seen this construction, which is made of such concrete slabs, not reinforced concrete, because the reinforced material is subjected to corrosion, and because of the calculation of the construction loading, it was shown that there is no need of reinforce, and because of that, the corrosion of construction elements in these old facilities occurs in a very, very slow and little manner. And now if we speak about the next generation of the storage facilities which we use, they also has the status of the disposal facilities, and they are made in a little bit different way with the use of the reinforced constructions divided into sections, and in these sections inside the waste were already loaded. The waste which were already packed into containers which were certified, which has certification necessary for disposal. But, these containers, they were put one by one with layers. After that, the whole construction was covered with slabs, and and after that, a hanger, metal hanger, was built after this storage facility, where also on the slabs of where it of the layer, the additional container waste were placed for storage. And so here you can see the main construction elements of it. Also here show the near field where the soil is extracted in order to make this area
Нарушенный грунт, зарыхлённый, он не такой плотный, как первоначально.
In order to in order to make this area less penetrated for the far field of it. Also, I cannot shown it on the plan. So the previous storage facilities were designed for low and low-level waste, very low-level waste, and for the special waste which we deal with, there was constructed a special storage facility. It was intended for placement of radionuclide sources of high activity of cobalt-60 and cesium-137. For these were made the deep wells with the stainless steel and concrete vessel inside, where sources were put by the curved tube channel, and this prevents provide physical and radiation safety of the sources of such activity. Nowadays, these storage facilities for sources are not accept any new sources because since the adoption of federal law, I will say about a little bit later, all the we are not disposal side. We and this way not make possible further retrieval of the sources. Also, there was special type storage facility for intermediate level waste, which at our company in past and now, in most cases, represented by metal elements from research reactors with reduced activity, and also in these channels in special vessels was storage ion exchange resins of intermediate and close to higher level of activity. Also, this storage was a placement for such difficult type of waste. It is sources, radionuclide sources on the basis of radium and thorium. And this object was under continuous ventilation in order to prevent accumulation of radioactive gas radon. Here we now go to the construction of the new type of surface storage facility, and it the preparers of the basis of it is quite it consists of multi-layers. They are here, and you can see that the preparedness of the place in the placement of this storage facility was all these layers. They are intended for not for prevention of penetration of radionuclides, and also to ensure the long-term good physical condition of the constructive elements in order to prevent the movement of soil and so on, because it is the surface storage facility where it has modular, I think, yes, it has modules where waste are placed in containers which are already conditioned, suitable for disposal, and they can be placed here for long-term storage for quite long period, but also the possible status of this construction is the disposal facility. After some preparation and creation of additional engineering barriers. So you can see here, if it will be covered with special layers of additional protection, it in further can be from it can be made a disposal facility. So as we at our site, as you have already seen, we have different types of the constructions for storage facilities. All of them have it is necessary to have procedures for their maintenance in good condition and to preserve fair properties for the engineering barriers of the construction elements. Some of these works are made on a regular basis, for example, snow removal works in winter, and also cleaning of the surface facilities if something goes, for example, wrong. But some of them are, for example, creation of preserving additional codes. They can be made after periodical examination of their condition. So in this case, can be made works of creation of additional layers. If, for example, we understood that water from precipitations, for example, go inside the storage facility with this creation of additional preserving coating. If we know that there is, for example, appears a contaminated part, the remediation works can be done. And also very important things in this, not daily routine, of course, but procedure. It is sampling and analysis on the basis of which can be said if we need to increase the durability of these or other construction. So because of that, for each type of storage, for each object here, there are procedural documents, technical programs, and methods of analytical control. Here you can see, for example, if in the case of assessment of the old facility, we receive information that, for example, there is water inside, or this upper asphalt layer is not enough for isolation of waste from precipitation. In this case, can be made besides this primary blanket, can be made an enhanced cover. For example, it can be concrete or clay ground with grass or clay and stone layer. It depends on the goal which we make. For example, to make better isolation from the frost in winter in order not to prevent the frozen of the waste packages, or for example to prevent the water input inside. Here you can see the creation of geomembrane coverage, which also has very good properties as for isolation from precipitation and also of creating the optimal conditions for storage. Okay, so here we also I want to emphasize that this site is under constant control by means of sampling from water object, from aerosols in the air, water, the grass, and so on. And we also have our own laboratories where these samples can be analyzed. When we, from time to time, it is we prolong the status of the storage facility. We need to understand the condition of the construction elements. And here you can see the exempt soil was removed, and by the non-destructive methods was estimated the construction elements. My colleagues have already said about this federal law, according to which there are four main participants of radioactive waste management. It is first, of course, the producer of waste, when special organizations who carry out processing, and then the national operator who is has national monopoly for it, which is regulated only by the state, who receive waste for final disposal, and the fourth side is Rosatom as an organization who provides the general management of the whole process of radioactive waste management. And here also, according to this law, it was already said that all the accumulated waste before the adoption of this law, before 2011, they were considered, according to this law, as historical waste for which management, processing, and disposal pay the state. While for the newly producing waste for storage and storage, disposal, processing, pay the waste producer. So also according to this law, by 2000, 2014, where was made the overall primary recording of all the radioactive waste accumulated at all sites, as well as was made the cadastre of storage facilities for type. And after this data received, the storage facilities were divided into two groups: the disposed according to the waste which we have divided into disposed waste and into special waste. And disposed waste, for example, when disposed waste, they ought to be processed to meet the acceptance criteria and further disposed. And while the special waste, in some cases, have received the status of uncertain status during some period of time. And for example, at our place, all these old storage facilities type will receive сейчас у нас получили статус пункта
Сейчас?
Да, до 2020 года.
Накопленные долговременное хранение.
So we received the status of still для старых хранилищ. For all our storage facilities, we receive the status as long-term storage facilities with by 2030. And in 2030, the status of some of them, for example, of the oldest, can be changed, and there will be question of the retrieving of waste and fair processing to meeting the requirements of the modern legislation. Here is the satellite photo. Unfortunately, I initially decided. So as for this status, it can be here is a very the place of the site is suitable both for storage and for disposal, because it is very important that such objects and storage facilities must be in a distance from settlements, from villages, cities, and also quite far, not in some cases quite far, but the underwater streams which it has must not influence any objects of hydrosphere. And in our case, it was because of the high level of this site. It is on the almost on the top of the hill here. So the prevention, it is natural prevention of radioactive dispersion into the objects of the hydrosphere. And because the status now is long-term storage, when we prolong it every 5 years by receiving the license. And the main element of this work for receiving the license is creation of the safety assessment report. In this safety assessment report must be, it is not obligatory, be included the internal events which can influence safety, external events, and strong external influence. then it is made from time to time. All these assessment, in most cases, we consider the most possible events, among which is the fall of radioactive package, for example, during transportation, technological operations, for example, some fire inside the storage facility, and this safety assessment report also helps, not helps, but if find any violations, possible violations, they are included in it, and in this case, there are instructions for activities which must be made in case of such event if it occurs. And also long-term storage and transfer to further for disposal or creation of a disposal facilities according to the law. It is a procedure that is very complicated and is in it a lot of factors are very important because it is estimated the dose of radiation from the works done, if it will be repeated, the cost of it, of the extraction, of conditioning, and so on. And the decision of making it changing this long-term disposal facility into, for example, for the extraction of waste from it, or making it as a disposal facility is very, and regarding the status of special waste, is very complicated, and a lot of factors must be on the scales. Only after the analysis of it can be determined to what it would be better. Well, thank you for your attention. Any questions?
One question of documentation. You mentioned, different classification of the terrorists. So I think you took it from IAEA website or from International Atomic Agency.
Yes, it was pulled from IAEA document, which is which is possible to be downloaded from the IAEA site.
I know that one actually. My question is, I also saw many different classifications done by another institution or another country. So the question, do you think that they have any plan to make all this classification to combine to only one? It's really confusing actually. I don't know. I'm just asking you because you're working on this topic. That's why I'm asking.
So yes.
Just my question: that do you have an idea that is there any plan to combine all these classifications done by several institutes or countries to only one? Because all the researchers or students are confusing the different types of classification.
Yes, I think that I understood your question. The classification of the IAEA is the basic one, and each country by the legislative system adopt its own one. So here, as I have already mentioned, these four categories are very similar to the EA classification. So we have high-level waste, high-level intermediate level waste, and intermediate level long-lived, intermediate level waste, short-lived, and low-level waste, and very low-level waste. We just according to the situation here, Russia adopted also to this classification. So it concerns liquid waste, which are injected into the geological formation, and also the process for uranium of the waste which occurs during the uranium mining. But to my mind, if all classification in every country should should have the basis of the EA classification, as we did here.
We have time. I have another question.
Yes,
we have time.
of course.
You also mentioned that for the final disposal, to check the radiation, is planning to create a valve, radiation valve. So I think to check the radiation, right? One of your slides.
I think you mean this one, yes?
Yeah. So
every disposal or storage facility must be in the field of each placement must be organized the examination wells from which sampling is possible in order to understand if there is any leakages, yes, and so on.
Yeah, but okay, for checking is okay, but in case of a leakage, also it can be freely leak to the atmosphere, right? So it's also not a good idea on that side.
But the level of the groundwater and the water which penetrates the input of water is not enough for group going out, I think. Thank you very much.
Let's share this presentation. Okay, perfect. Yeah. Nice presentation. Thank you. I'm sorry. Hocam o kategorize eğitim olayı gerçekten saçma söylüyorum. Yani her ülke, her kurum, her konusu böyle bir şey yapıyor. Gerçekten kapalı klasik bir şey. Yani bu toplanın yapın bir tane. Yayınlayın bu diyelim. Hangisine göre yapacaksın? Belli değil.
Katı var, sınırı var.
Low level base var. İşte seviyesinin hangisinde hatta gerisi o kadar bir şey.
Ya işte var. Öyle radyoaktif işler radyoaktif şu. Öbür tarafta aktivite var. Yani kayıtsız
aslında çok şey değil. Ama bütün hani uluslararası şeyde geçerli olsa toplamın zarar verirse mantıklı.
böyle süreçleri. Tamamen işte katı malzeme bir kere olurken gaza dönüş. Evet. Yani şey de değil, yani nasıl yeri değişiyor ondan sonra bir yaparken öteki bu sefer ürün gidiyor, metodom yapıyor, ama dikeyi yapıyor. Ama da problem yok da. Arsa dikeyden sonra önüne sert bir şey gelirse direkt şey oluyor. Tekrar yanında radyasyona dönüşüyor. Yani beyaz ışık aldığında şunlar bunlar. Bitmiyor ki şey. Zırhlamayı such needs for this. About 200 kilometers.